Going. Hello, everyone. Welcome to Deep Tech Showcase's Aerospace and Defense Showcase. I see a lot of people in the crowd that I'm familiar with and some new faces, so that's awesome. Happy to have everyone here today. Today is going to be a little bit of a longer showcase than we've had in the past, right? We've done actually a few years ago, we did a 2 day Aerospace and Defense Showcase because there was so much demand. This year, we're doing a 3 session showcase. Everyone who's on, I'm excited to be hosting. For those who want to stay for the entire thing, feel free to. For those who have to stay on it just for 1 or 2 sessions, that's fine as well. But we're really excited that we have a really good lineup and some heavy hitters here. So what is Deep Tech Showcase? What's the vision? What's the point? That's a great question. What we do is we help companies bring their tech to market by building this ecosystem around them. We've been doing it for quite a few years now, and we're really happy with the results that we've seen and kind of the traction that we've experienced from it, and we're excited to continue that. And so in that ecosystem, right, it's easy to call it just an ecosystem, but in that ecosystem, there are, three major, or four, depending on how you count major players. One is startups, two is tech scouts, and that's both on the government side and the corporate side. So it's not just, that's why it might be four categories really. And then lastly, and not leastly, investors, right? To make all of this stuff happen and actually occur, you need all of those, at least for the dual use that we're dealing with and that you'll probably see here today. They need that. They need all three. So, where are we now? We're at a showcase event. This event is held over Zoom. And what we're trying to do here is we're going to have companies present 5 minute pitches, followed by 5 minutes of Q&A in front of a panel that we've selected. And hopefully through that, either A, will pique some of the interest of the panelists or pique some of the interest from the attendees and hopefully make a connection. That being said, if anyone sees a company that they're interested in talking to, feel free to email me. I think my email's on the Zoom invitation or in the event, or if you reply, I'm pretty sure you can find me. I'll leave it in the chat as well. In addition to that, if just so the panelists know how we're running this event is we like to do the hand raised sign in Zoom, which if you go to your Zoom bar under actually it's under reactions and actually for me currently I don't have it, but basically there's a little hand raised emoji. If you don't see it, like I'm currently experiencing issues, what we could do is we could just blurt it out and we'll try to manage it equally and equitably so that everyone gets to ask their questions. That being said, we are a little bit on a time scale. So if it gets a little bit too extreme, we'll cut it short. But really excited to see some really good questions. And then there are also guided introductions. So that is essentially we have a bunch of stakeholders and folks in our ecosystem, and we kind of have a pretty good idea of what they're generally looking for, and we're happy to send profiles their way. If it's a good fit, fantastic. We'll make an introduction. If not, that's fine too. I have thick skin. I'm not nervous about that. Upcoming showcases, we have the IoT, Cyber, and AI showcase on February 25th. Looking forward to seeing everyone there. And then we also have the Energy and Clean Tech showcase on March 25th. And really excited to see everyone there as well. Next up, we are having a word from our sponsor. Hello, Jacobs will be telling a few words about Eagle Point funding.
Awesome. Thank you, Osher, for the intro. So I'll keep things brief. I know you're all here to talk about cool technology and not Eagle Point funding. That said, my name's Hillel. I'm an account executive over at Eagle Point. Essentially, at Eagle Point, we help deep tech companies take their groundbreaking tech and turn it into a concrete plan to secure government funding, investment, initial customers. So most teams we have met, they have strong tech, but they struggle with three things: knowing which opportunities to pursue, what's actually worth pursuing, how to pursue it, and the reason we're here today, obviously, of getting in front of the right stakeholders. We try to solve those problems under one roof. So first, we run an aggressive grant strategy across SBIRs, BAAs, OTAs, all kinds of other incentives. So we build a deep funding pipeline rather than just a one-off submission. Secondly, through the Deep Tech Showcase ecosystem, including our Defense Accelerator, which is going on currently, formerly known as our MOU Club, TACFI, StrapFi, Prep, we make warm introductions to stakeholders who can help support our proposals through LOIs, letters of support, customer memorandums, et cetera, et cetera. So the network consists of former CTOs, program managers, primes, investors, who aren't just there to listen to your pitches, but we actually help shape your pitches and perfect our pitches. And then finally, we actually commit to outcomes, right? So unlike a lot of other firms out there, we put a return on investment commitment behind our work, and we only that's because we pretty much only partner with technologies we believe we can win with. So if you're building something disruptive in the aerospace and defense, energy, advanced manufacturing, any other deep tech space, and you want to cross the valley of death with Eagle Point, leveraging government money, VC money, feel free to book a call with me. You can use the QR code on the screen or the link that I just sent in the chat. I'll be a fly on the wall throughout. I won't be here, but if there are any questions that come up about Eagle Point funding, I will be here to answer them, and I'll drop my link occasionally throughout the showcase. Thanks, Todd.
Refunding that mute button is a real challenge sometimes. Thank you, Hal. Thank you for that. And yeah, definitely leave your contact info. And then now we will quickly run through the agenda. Um, right now is the opening presentation and introducing the panel. We're going to start off with Macrove, followed by Sentinus, Enosis, Xenodrone, and Lemco, and then session two for those who are staying are, and I hope a lot of you guys do stay, but we'll have is in zero through wave Helios, Absentia, Navia, and Bullseye. And last but not least, for session three, we'll have Caliburn, Seafloor Systems, Sereniasat, and Aeronaculus with a thank you and a farewell. With that, I'm going to stop sharing my screen. And we're going to quickly go around the panel. What I'd like is everyone to say hello. I know that this is this is a pretty diverse event. There's a lot of different types of technologies here. So if you want to quickly say your name, where you're from, or which organization you're representing, and then also which technologies within the aerospace and defense umbrella interest you, that'd be awesome. And so I'll kick it off. So let's get going here. Let me just pull it up on my screen. Dana, you want to go first?
Yeah, my name's Dana Teague. I'm the Power, Thermal, and Energy Storage Lead for the Laser Division of the Directed Energy Directorate. Those are pretty cross-cutting technologies, so I'm generally interested in anything related to specifically directed energy, um, energy storage, power generation, and advanced thermal management and electronics packaging techniques.
Awesome. Thank you for joining. Next up, we have Mark Morgan.
Hi, Mark Morgan. I'm from the Air Force Civil Engineer Center. Really just interested in anything that'll make maintaining Air Force installations easier, faster, less manpower. It can be in the energy sector. It could be in the structural, roads and grounds, infrastructure, but really just looking for anything to make us go faster and cheaper. Thanks.
Absolutely. Thank you for joining. Next up, we have Martin Ooft.
Hi, yeah, on from GP at Quest Venture Partners. We're an early stage firm based here in Menlo Park, California, doing pre-seed, seed, and Series A for all kinds of things deep tech.
Absolutely. Pleasure to have you. Next up, we have Marissa McGinnis.
Hi, good morning. I'm in Silicon Valley in Burlingame, and I'm here with myself, and I do a variety of investments, startups. So currently I'm interested in defense, space, and digital health. And I've had a couple of exits, so I have some extra money.
That's always a good thing. Happy to hear. Pleasure to have you. Next up, we have Alex Hamilton.
Hi, good afternoon, everyone, or good morning. Alex Hamilton, Craft Capital. We provide financing for small cap, micro cap companies. My focus is on basically anything that's deep tech or aerospace.
Absolutely. Pleasure to have you, Alex. Next up, we have Paul Garcia.
Hi, Asher. I'm Paul Garcia, contract support for the Air Force Office of Energy Assurance. That's Installation Energy Directorate, which means fixed utilities. So anything energy or water that is connected to utility, we look for energy resilient solutions across all 200 Air Force bases in power and water. I'm going
Nice.
to turn off my video because I'm seeing bandwidth issues for here today.
Okay, all good, all good. Um, Bara, you're up next.
Hi everyone. Bahar Haji Saeed, Technology Scouting Director for BAE Systems. We are part of our R&D group called Fast Labs. So therefore, we cover basically everything from AI, ML, autonomy, sensors, technology, and etc. Glad to be here.
Absolutely, pleasure to have you, and it's good to see you again. Um, Next up, we have Craig Gavin from OpAmp.
Yeah, hi, I'm Craig Gavin. Thanks for having me. OpAmp is, I'm in Vienna, Virginia. OpAmp is actually short for Operational Amplifier. We are an early stage deep tech fund. We have about 15 investments currently on the books. Most of them are in space. I'm a former spacecraft engineer, and we see a lot of space deals and have a lot of insights into that category.
Nice. It's a pleasure to have you here.
Sure.
Next up, we have Dustin Baker. Okay. Um, I don't think Dustin can actually speak, but he did message in the chat that he's at Elson Air Force Base as the Director of Innovation. Um, and so that's Dustin. Happy to have you here, Dustin. Next up, we have Sarah Jones. Sarah, you want to introduce yourself?
Great. Sarah Jones, I'm an investor at InQtel. We invest in partnership with our federal partners to further mission capabilities, particularly for the IC and the defense community, and invest across a number of areas from AI to advanced systems, whether that's space, air, ground, sea, and as well as connectivity and compute.
Awesome. It's a pleasure to have you here. Pleasure to have you here. Um, with that, we're going to move to the presentations. We're going to start with Macrovay. Matt, whenever you want to start sharing, I think you should be able to, hopefully.
Yes, I can.
Perfect. Beautiful.
All right. Good to meet everyone. My name is Matt Lubinsky. I am Director of Business Development at Macrovay for defense and commercial projects. A little bit about us. So we've been in the material handling space for over 40 years. A majority of that was installing material handling systems into big warehouses for Amazon, FedEx, UPS. So those like mile-long warehouses on the side of the highway, pretty much anything that went in there to move or store materials, we installed. The past 3 years, we've kind of been looking at how we can better optimize the processes in those types of warehouses using automation, specifically robotics, to really kind of eliminate the need for human intervention within a warehouse operation. So the past 3 years, we've been building systems that were awarded a AFWERX Phase 1 SBIR, 2 Supply Chain Excellence Awards. These systems are demoed at a technology center in Atlanta, and then we also have offices in Chicago where I'm located. Just kind of give you an idea of what these systems look like. We don't actually manufacture robots. We have about a dozen partners that we can pick and choose from depending on the use case. So we go into conversations with the customer, whether it be commercial or defense, and say, what are the issues you're having in your warehouses? What do you want to optimize? And we kind of pick and choose which robots are best for that and design a system around it. So we do have a proprietary software that runs these entire systems. It's basically the middleman between the robot's API and the end customer software, whether that's a WMS, inventory, ordering system, to basically combine all these systems together. Now, again, we do commercial projects, but Kevin, this is kind of defense related. I'm kind of going to go over some examples of what our defense systems look like. First, we've designed a system called the Autonomous Material Delivery System. We actually designed this in conjunction with Joint Base Charleston. They have a new warehouse on base. They're looking for a way to basically robotically store, pick and kit parts, tools, materials, anything needed. So when a pilot's coming back from a sortie, they can send a request saying, I need this part, I need these tools. And the robots basically go and find where those are located within these bins. pull them out robotically using a six-axis arm, put those into a single bin, kit, cart, whatever's needed. And we can actually have a robot go out and deliver that parts and tools to a technician on the flight line, or they can actually be stored in these kind of shipping containers on the flight line. So when the plane does land, they can actually have the robot go and pull that kit from the shipping container and bring it out. So these are very, very modular. It's very simple. It's racking, robots, and bins. So you can start small and kind of grow as the needs grow. You can move racking and robots from one base to another. It's very, very modular, very, very customizable, which also makes it a lot more reasonably expensive than kind of installing larger robotic systems that you typically see in warehouses. Another thing we have is kind of these more commercial off-the-shelf products. And these are actually basically shipping containers with warehouses built inside of them. So this is very good for expeditionary forces, contested logistics, where you need to have a basically warehouse operated within a remote area. So inside of these shipping containers, we actually have, again, the same kind of concept of racking with bins on it. A robot can pull the bin when a certain material is requested, bring it to that six-axis arm, and that can kit together MREs, ammunition, trauma kits, anything really needed that's requested in the field. Again, since they're built-in shipping containers, they're good for harsh environments, weather, and they can be moved really easily. So let's just say that you have a certain remote forward operating base set up. It's contested now. There's forces coming in on you. You can easily pack these shipping containers up, move them to a better area. They fit in the back of a C-17. So this is really good for mobile applications. Just kind of high level, how this impacts the warfighter. Again, we're really trying to do workforce optimization and have the warfighters concentrate on more important things than being in a warehouse and kitting together, whatever is needed for a mission or a sortie. So 90% cheaper per pick. We're reducing material search time, picking and kitting cycles, kit accuracy, and giving these to robots with really no manpower needed. These can run 24/7, no breaks, no sleeping, no sick days as I need right now. Um, Given the software is also AI optimized, so it is a vision-based system with that six-axis picking kitting arm, which is really good with accuracy of picking the right materials. It also optimizes bin placement, so if there's something that gets picked a lot, the system ends up knowing, okay, I need to move that bin closer to the picking and kitting station, closer to the front of that container. So it again really pushes up the system throughput time of the system. And lastly, inventory management. We're able to track every single material that is stored and moved within these bins. So you have very, very high accuracy in inventory management. So what's next kind of for us, what we're looking at? On the defense side, we are currently actively going out speaking with different bases to see if these systems would be needed within their depots. They can even be as large as shipyards. So these are very flexible and modular. Also, we're continuing to work with Joint Base Charleston on a phase 2 SIBR, but any collaboration with those in the future, we're very interested in. Also look into these open market FARs, which we're kind of new to, but really exciting, especially in terms of pilot projects. On the VC side of things, we're also actively speaking with VC firms, looking for additional capital at this time to grow our sales and engineering team, build additional demo units so we can actually do demos across the country versus solely in Atlanta. And given that we're kind of a newer startup, looking for kind of broader marketing push to get in front of more eyes. So with that, I guess any questions running through in 5 minutes quickly.
Nice. As I mentioned, yeah, Marissa, you want to go first? Go ahead.
Okay, so this is software, yes? And so you're hardware independent?
That's correct. Yeah. So proprietary, I mean, we have patents on some of the designs of the mobile systems, like the shipping container. We actually build these on top of flatbed trailers as well. But kind of the big proprietary concept for us is the software that runs it.
What about the robots at Amazon? What can you say about that?
So I know they bought that company a while ago to basically have their own in-house robotics company. I think they're only really interested in just doing their own in-house thing. I don't believe they sell their actual robots to other markets. I could be wrong. But yeah.
I mean, you selling to them.
So again, since they have their own internal robotics company and team, they were a customer of ours in the installation side. So of course we're open to it. I just don't know how much they're interested in outside help, given they have basically a whole division running robotics internally.
Okay, thank you.
Yeah, of course.
Sure. As I mentioned, if you guys want to blurt out, if you can't find the reaction button, feel free.
Do you have a
I guess
sense for the power requirements on the containerized version?
Yeah, so actually there's two different ways we're powering these now. One, just a standard outlet if you have a close power source, but we're also running these on gas and solar generators when we're doing kind of our remote demos.
I have a question if no one else does. Or
Sure.
Sarah, do you have one? I saw you
No, I was
unmuted.
just trying to come off mute and say thank you.
Yeah. But yeah, what can you talk a little bit more about some of the traction you've previously gotten from the government?
Yeah, so as I mentioned, Joint Base Charleston, we worked really closely with them on our kind of phase one SBIR that we were awarded. They're really interested. I mean, again, the big thing for them is kind of the lack of resources within their warehouses and the ability to basically robotically do all of the work that was traditionally done in there by people. So that's kind of been a big push for us. On the commercial side as well, we actually have two proposals in the pipeline with pharmaceutical companies wanting to move basically medications, sort them to be sent out to pharmacies and then direct to patient at home. And then also on the food and beverage side, we're actually speaking with two global basically snack companies that want to kit together orders for supermarket stores and then also robotically kit those mixed bags of chips that you can get at the grocery store where it's like Lay's, Doritos, Fritos. Basically have robotics put those packages together versus having humans do it. So yeah, getting a lot of traction on both commercial and defense side.
That's really cool. That's
Yeah,
really
thanks,
cool.
Asher.
Yeah, absolutely. Well, let's see. There's something in the Q&A. Let's see. Yeah. Oh, the decks will be provided after the call, I believe.
Yes.
Th Thank you, Matt. I really appreciate it. Feel free to
Thank
leave your
you. Thanks,
contact in the
everybody.
chat. Yep, absolutely. Next up, we have Sentinus.
We
Perfect.
do indeed. Hi, everyone.
Howdy.
So my name is Jonathan Duff. I'm the Chief Business Officer at Sentinus. I'm actually joined here by founders Matt Rabinovitz and Jonathan Sheena, who together have built and scaled numerous multi-billion-dollar technology businesses, including Natera, a leading $33 billion precision diagnostics company, and our recently appointed CEO, Ben Cheatham, who's a senior defense and technology executive who has deep experience of helping the US DoW adopt and scale mission critical AI, which is fitting because Sentinus is a physical AI software platform for defense, security, and public safety. We operate across mission defense, patrol support, and counter-incursion missions. We provide persistent situational awareness and rapid response using autonomous drone-agnostic systems. Our physical AI reacts to what it sees in real time inside existing military and commercial command and control environments. We're trying to solve a specific problem: military bases, patrol routes, and increasingly critical infrastructure. Incursions of both humans and UAVs remain a persistent force protection problem. Today's detection relies heavily on periodic patrols, fatigued personnel, and fixed sensors, all of which leave gaps. On forward patrols, the problem worsens as units are exposed during movement, forward ISR is limited, and subtle indicators are often detected too late. This is not a sensor problem. This is a decision velocity and persistence problem. And true base protection requires layered defense, and we have the capabilities to contribute significantly to that family of systems through our product, Sentinus Defender. Sentinus Defender closes that gap by applying physical AI to Overwatch and patrol missions. And we structure the mission into 4 operational capabilities: continually monitoring an area of interest, quantifying movement patterns and ingress and egress in real time. And when behaviors of vehicles or people deviates from baseline, our AI system detects those anomalies, assigns risk, and generates actionable alerts. And the system can then locate and track people or vehicles autonomously, maintaining custody whilst alerting operators. And finally, Sentinels identifies targets by capturing high-res imagery and vehicle identifiers, including license plates on demand. And all of this happens within a single operational picture with a human always in the loop. I'd like to share a couple of examples of this. So in this instance, in South Africa, the operator had to find an area of interest around an outbuilding which was assessed as a potential gang operating location. Once monitoring is initiated, the system establishes a baseline and then continually counts and logs all vehicle and personnel movement in and out of the area. And this capability can operate independently, or it can operate in combination with behavioral anomaly detection and other workflows. In this slide, we're going to have a look at suspicious behavior. Here, during a routine residential patrol, the system identifies an individual exhibiting anomalous behavior. Object detection highlights the subject, and then the AI escalates the alert based not only on location and posture, but on accumulated contextualized evidence. What you're seeing is the AI respond to the situation. In this next example, provided by one of our public safety partners, a drone provides overwatch of a known narcotics location before, during, and after a DEA raid. As agents arrive on scene, two individuals are prioritized by the system and tracked. The suspects flee the location, are autonomously classified as high risk based on their movement patterns, the direction of travel, and their location. And again, a critical alert is issued. What you're seeing is the AI system defining the problem. This is not written by humans. This is written by our AI. And in this final example, what you're looking at is auto ID and search. Prior to launch, the operator tasked the system to search for a specific vehicle, in this case, a red Toyota pickup truck. When a candidate match is detected, the system raises an alert. Command then authorizes autonomous repositioning, and the drone executes an automated fly and ID sequence, capturing that high-res imagery of the vehicle and license plate for verification and cross-reference. That's an example of vehicle. We're also building to people as well. So Sentinels is designed explicitly for layered defense, operating in the C2 and decision-making center, and integrating multiple sensors, platforms, and partners into a single operational picture. For example, we're actively integrating Parrot to support a US Department of Transport and government-compliant use cases. Platforms like Heaven, Starling, Vantage extend that mission envelope, longer endurance, higher payloads, greater range, while Sentinels provides the intelligence, autonomy, and command layer that makes those capabilities operationally meaningful. Our platform has undertaken thousands of remote BVLOS flights and missions, and within the security market, we're already deployed with public safety, community security organizations, and have a number of government and commercial pilots in development in the US and across the world. We also have a growing number of strategic partnerships, such as MITRE, who are exploring Army use cases with us and will also be deployed to their range very soon. A Gold Key from the US Department of Commerce for ex-US opportunities. And on the public safety side, Central Square is exploring a deep integration with Sentinels for their CAD system. Our roadmap, to finish off, compromises the production of existing capabilities combined with critical and edge capabilities. What we would love to talk to you about is how we can work together to test these developing capabilities and support gaps in that layered event concept as it relates to you. Thank you very much. And I'm sorry, Asher, for running over. I know it's like 6:30.
You're good. You're good. All right. Opening up the floor to questions. Marissa, go ahead.
So what's the hardware component?
We're
And
entirely
you
drone
have-
agnostic. So again, like the
Drone-
previous, we are purposefully drone agnostic. We integrate with any drones that the sponsor wishes to use.
Okay.
I'll
Who's
just-
the software
it's-
platform then?
It's Matthew Rabinowitz here, and Jonathan Sheena might want to comment on the software. I'll just make a quick comment. We currently work on the DJI drones because although those are not great in the United States, they are the best drones in terms of performance versus cost. So that's very relevant for international platforms. In the United States, we are integrating with Nokia, and there's a whole pipeline of other integrations that we're doing to transition our software capability from one drone to another. It's not immediate. It takes about, say, 3 months to enable another drone. But we're currently doing Parrot and Nokia, and then after that, we'll do Heaven and the series of other drones that Jonathan mentioned. Sheena, do you want to talk about the software?
This, I'll just add that the software is a SaaS-based platform that can be on-prem if needed.
I would raise my hand, but for some reason the button doesn't seem to exist on this web client in Linux. My big question is, have you looked, and it might be early days yet, it sounds like this is something you'll likely explore with your MITRE efforts. Have you looked at integration with C2 systems for queuing other effectors towards what you detect? How you would take in a radar feed, how you would export a queue to a radar to go tell it to look somewhere. Is that in the roadmap? Is that in the pipeline at the
It's a
moment?
great question, Dana. Actually, Jonathan Sheen is probably best placed to answer that one, but the answer is yes.
Yeah, so we integrate with a number of separate systems. It depends on when you talk about C2 systems. Yeah, there are a number of different ones, so it depends on where you want the interface to be. But for systems that provide CUAV input for example, for counter drone detection, we integrate with CAD systems for doing dispatch. We have preliminary ATAC integration for personnel tracking. And we also bring in we can import or export live feeds from our sensors or from other sensors.
That's excellent to hear, because that's rapidly becoming a thing that we know we need to have, is this sort of integrated battle space management.
Yeah,
absolutely.
You'll hear FAD C2, JC2, all these fun, and
Pico Grid.
NGC2. Yeah. They're still trying to figure out what that next generation looks like, but I believe the idea is to have a fully networked, interconnected kill web, for lack of a better term.
That's the idea. Whether or not that actually happens is to be seen. But yeah, we are aware of it, and we're trying to make sure we integrate into the total solution as that layer. That's where we want to sit.
Yeah.
Excellent. You're thinking about the right things.
Great.
Thanks, Dana.
I'll let the panelists.
Chat.
Yeah, there's some in the chat. I'll read them to you guys. Bo asked how do you navigate potential conflicts of interest, given that you've been using DJI drones? I think you covered that a little bit, but if you want to expand on it, that's fine.
Well, since I raised that, I'll comment on that. We started as a nature conservation project, which was like a pet project of mine 4 years ago. Because before October 7th happened, I used to be more focused on tree hugging, and I was volunteering for the World Wildlife Fund. And we came up with this technology where we could explore nature conservancies all over the world using drones and Starlink. And for that, it was clear to use the DJI drones. And the DJI drones do have incredible, performance advantages relative to the cost of all the other systems. As we started to focus on security, which was about a year ago, and DOW applications, which is about, say, 3-4 months ago, we started to integrate with a bunch of other drone platforms. So we started the integration with Parrot and Nokia about 3 to 6 months ago. We're going to be doing the integration with Heaven starting in about 2 months. And we've got this pipeline of other systems that want to integrate with us. And there's a little bit of tweaking. There's various doodads of each of these drones that you got to make work. So it takes about 3 months. But the system was developed in the last year to be drone agnostic for DOW applications and security.
Let me just add one more thing, that for a DOW application, the installation would be completely separate from the one that is available for ex-US and public safety and others that are using DJI. So DJI would be there would be a gap between the two.
Yeah, sorry, Sheens. There's like no sharing of information with DJI at all.
No.
Yeah, nothing actually. Even with DJI, there's no sharing of information.
No, we
that's a
covered
whole
that.
new conversation.
Sure. And then the last question, because I think this is all we have time for, but they wanted to ask about air to ground and then also ground to air, meaning, how effective is the software when it comes to, the different use cases that could potentially be used.
I'll jump in, Matt. You can. There's air to ground, ground to air, and ground to ground. uh, ground to ground is sort of well understood. There are a lot of there's those the models for detecting things at kind of eye level are more ubiquitous. We have spent a lot of time tuning our models from ground to air to be better than what you can get off the shelf. So we're better at detecting people, cars, plates, et cetera, than vehicles than what you can get elsewhere. For ground to air, there's I think that's where we want to start talking about R squared and where you use where instead of trying to look visually at what's in the air, you're using RF you're using RF sensors to detect what drones, usually drones or other equipment, are out there through that mechanism, and that's something that's a partnership that we have that's on the slide right here. Matt, you want to add?
Yeah, so R squared does a spectrum analysis. It's a very good technology that does, full spectrum sweep, identifies transceivers that are usually drones, but can be ground transceivers as well. I'll just mention that in terms of these different scenarios for looking at visuals, we've become pretty good at fine-tuning our models. One of the capabilities that is such a big deal for Sentinels, why I think this will be a multi-billion-dollar company, it's piggybacking on this new capability in technology, which opens up a whole vista of opportunity, which is the ability to generate video to spec. So with the new NVIDIA capabilities, we can pretty much, we're sort of at the point in the last few months really, where you can generate a whole range of thousands of videos to spec, and you can train the AI on those videos. So for all of the usage cases that you guys might have, we would need to do fine tuning to make them nice and rugged and robust. And a lot of that fine tuning is going to leverage the ability to create AI videos with the latest NVIDIA engines.
Thank you so much. I think that's all we have time for, but I see some more questions in the chat, so I highly recommend that you guys reach out to those folks that are asking questions in the chat. And yeah, thank you so much for the presentation. It was really, really
Thanks for
interesting.
having us. Appreciate it.
Yep,
Thanks, guys.
absolutely. All right. Next up, we have Inosys, and presenting will be Stephen, I believe.
Yeah. Hey, Asher.
Howdy.
How are you?
Doing well.
Awesome. All right. Can everyone see my screen?
Yes.
Excellent. So, my name is Steve Cox. I am the CMO of Inosys, and today we are going to talk about adaptive decision analysis and performance training. First, a little bit about Inosys. We were founded in the year 2000 as a woman-owned small business. We have a really large manufacturing facility in Salt Lake City, Utah, in the Western United States. We have more than 35 engineers on staff, and in-house we fabricate microelectronics. We do additive manufacturing. We do packaging and testing. And just recently, we have started a new line called solid state vacuum devices, or SSVD. These are devices that can withstand extremely high temperatures in excess of 650 degrees Celsius, very high radiation levels up to and exceeding 100 megarads. So they're great for satellites. And if you'd like to talk about that, I'd love to tell you about that too. But today, we are going to talk about the situation for the Department of War right now. With technology changing at a really rapid pace, especially driven by AI, not only warfighters using AI in the course of their daily lives, but also just the fact that AI is moving the technology at an incredibly rapid pace, especially in areas like hypersonics, but also cyber, space operations, and information domains. This creates a scenario where we have to be really scalable in our training. We have to be agile in upscaling personnel that we already have, and we have to be able to give them the ability to make rapid decisions in realistic settings because we cannot train for absolutely every single scenario. Which brings us to experiential learning. So experiential learning really relies on mental models, creating mental models that allows warfighters to adapt and innovate in situations that they might not have seen before. This creates a dynamic environment where they tend to perform much, much better when they are in the real world. It's been proven effective time and time again. With adaptive decision analysis and performing training itself, we use simulated situated cognition. So the trainee is directly in a simulation. They see what they will see when they are actually in the field. It leverages adaptive and interactive coaching. So the trainer themselves, they are able to see every single thing that the trainee does in the environment. It's recorded, and then the trainer is able to adapt their courseware going forward. So it's not a simple static course that is a sort of traditional classroom environment, which is really important right now because attention levels are plummeting. We all know it with cell phones, with TikTok, we really do have a focus and an attention problem in society today. And when it comes down to decision making, anytime that we can allow them to, in the real world, what would be a potentially catastrophic decision, we can allow them to make those in a safe environment without dire consequences, we take it. And the results have been overwhelmingly positive. We on a scale of 1 to 10, we average typically a 9. And just some of the feedback that we get in the field, I will just read one of these. So, like that the simulation was realistic, interactive, and the parameters changed in real time. The fact that this is a realistic scenario is incredibly impactful for our trainees. And in conclusion, before I drop you into just a moment of the sim, I don't know how we're doing on time, but right now, the rapid pace of technology innovation is outpacing our ability to train people how to use it. And because of that, we have got to be adaptive in the way that we do train people, and we have to keep doing it throughout the entire course of their career. And really, again, I know I've said this a few times, but that immersive nature of the simulation is really key. Let trainees see what they're going to deal with, make decisions within the simulation, and then record that and reflect on it. And with that, I'll just show you the simulation. This simulation is actually for grid operators. This came out of the fact that um, within utility companies right now, power generation, we have data centers that are popping up all over the entire country. Those data centers need more and more power. And at the same time, they are pulling from the same candidate base as utility companies. So, and they're winning. The candidates are going to work for the data centers. It takes about 4 years to hire an employee, train them, and get them completely competent to become a grid operator. We need to take that amount of time down as much as we possibly can. And according to Dr. Bob Corney and others in this field, it does tend to reduce the amount of training time by about 25%. So in this scenario, the trainee is looking at the grid. This is what they see on a daily basis. You can see at the top, there are a number of different alarms going off. These are use cases that the trainee has to resolve. They go to a geographic map of what they would see in the simulation in the real world. They communicate with the ship supervisor. You can see that they have different options. They can speak with the ship supervisor, reliability coordinator, product engineer, etc. They're talking to an AI. So this is AI based, each one of these different roles, and the training material of the AI is NERC. That is the governing body for utility companies in the United States. So this makes it extremely dynamic and it makes it extremely realistic, and it also makes it extremely accurate. They go in to adjust the power. They do something really, really dangerous. So we let them know immediately because in the real world, this could shut down a part of a city's grid. They continue. This is called a one line, and they can see over in the upper left-hand side that they are actually remediating the problem. So now they've solved the use case. We drop them into an after action review and we really walk through. You can see across that top bar, every single thing that they did within the simulation, we have recorded. We walk them through this step by step. We ask them a question. We record their response. We show them what an expert would have done in that case. And then we provide supporting documentation. And then we let them evaluate the response. Is that what an expert would have done? What you did? Is that close to what an expert would have done? I took this, and so my answer was close to an expert's. And then we drop into the LMS, learning management system. This is what the trainer themselves see. So we can see the number of attempts by each trainee, the number of points that were deducted on average, and the total number of average violations within that use case. So from this information, they can adjust how they go forward with the training, where their strengths, where their weaknesses, where they really need to focus.
Steve, 30-second warning.
30 seconds?
Yeah.
Perfect. So we show them the courses that they have. We allow them to create new courses. They can create the questions that they want to ask. We give them the ability to upload supportive images. And then really where our areas of interest, where we initially see this having the most traction, really in places like the First Term Airman Center, FTAC, expeditionary training offices, test and training ranges, including the one here in Utah, and then crash damaged or disabled aircraft recovery. If there are any that I've missed, we would definitely like to hear from you. And that's it. Thank you for your time.
Absolutely. There's a lot of yeah, Marissa, go right ahead.
Hi, which AI model are you using?
Um, I don't want to answer that and be incorrect, but it is an open source, readily available AI model that we have. It is hosted on local servers. And really that transmission just between the only outside transmission that we really need to go is between our server and NERC and back.
Okay, so you don't know which one it is.
I'm the CMO.
That's okay.
But Marissa, I'm going to get back to you if that's okay after this, because I do know that's an interesting question given the number of models that are out there.
Yeah, because there are a lot of models out there. Okay,
Yeah.
no problem.
Sure, Craig, you're up.
Yeah, hi Steve. I apologize in advance. I know you didn't want to talk about this, but I have an immediate need.
Mhm.
On the solid state vacuum device, I assume it's an amplifier. So, does your amplifiers operate in W band? And if so, what do you have as your P rating? And do you have any flight heritage at this point?
Okay, Craig. So I am the CMO. I don't know. Is Dr. Who on the line?
Let me see.
It doesn't sound like she is, but I know we do operate in S-band. I'm not sure about the second part of your question, but we are already testing with NASA for Venus probe on the surface that will use S-band to communicate all the way from the surface of Venus to the surface of Earth without the need for intermediary satellite communications.
Okay, I'll send you a separate email
Mhm.
with the ask. Thanks, Steve.
Thank you.
All right, there's one question in the chat. The solution is similar. There are other solutions similar to your project that are not so new and are well developed in large companies such as Boeing. What's the new AI development or proprietary IP that sets this aside?
Um, so I really would say it is the AI. I do know there are tons of LMSs out there. A lot of them are, bolted into simulations, but it is that combination of AI within the simulation that is really based, its training material is based on NERC. So it's extremely accurate. It's extremely dynamic. And that's only our first foray into AI. We are also, because we know trainers are absolutely slammed with time. A lot of the utility companies that we work with, the trainers, in addition to them being trainees, now because they are so short-staffed, they have to go in and actually do the grid operation jobs themselves. So our next move with AI is to make the course training much easier. So using AI to take standard operation rating procedures from that specific utility company, use that as training material, and then assist the trainer in making new content.
And then the last question, unless there's a live question from the panel, which is always more interesting than me reading questions, but I'll read unless anyone speaks up in the next 5 seconds. 4, 3, 2, 1. Tie goes to me. Innosis, what is the content source? Do you guys create the content, and how does this user or student interact with the course?
So we uh, have a CMS, a content management system, where trainers can log in and create their own course content. We have come up over and over with the scenario that trainers just don't have the time to do this. So in those cases, we have subject matter experts on staff who can create the content for you, populate it for you, and then that is published, and then it's just made available to your trainees.
Yeah. Awesome. Thank you so much, Steve. Thank you for the presentation.
Absolutely. Thanks, Asher.
Yeah, pleasure to have you. Next up, we have Zenadrone, and I believe Sam will be presenting, if I'm not mistaken.
Yeah, sure. Thank you. Thank you guys for joining us today. As Asher said, my name is Sam Chen, and I am a business developer with Zenadrone. We design and deploy autonomous aerial systems built specifically for dual use missions, meaning that the same core technology supports both commercial industries as well as government and defense operations. Okay. Across industries and government agencies, there is a shared challenge that we recognize. They need persistent situational awareness, high quality data, and reliable autonomy, often in environments that are remote, hazardous, or time sensitive. The human operating systems, as you guys know, are costly, risky, and slow to deploy, while single purpose platforms limit adaptability across missions. At the same time, GPS communications and PNT signals are increasingly contested or degraded, creating additional operational risk. That's kind of where Zenadrone comes in, where we were built to close that gap at a platform level autonomy that scales across missions instead of being redesigned each time. So what makes Zenadrone a deep tech company is our systems level engineering approach. Our platforms basically integrate advanced autonomous navigation, obstacle avoidance, and mission execution. We combine multi-sensor fusion that includes LiDAR, RGB, thermal, and multispectral sensors with secure communications and mission configurable software. So the result is not just a drone, it's actually a fully integrated autonomous system designed for endurance, redundancy, and adaptability in real world operations. We're also seeing a growing challenge around operating in contested and degraded environments. In many real world scenarios, GPS, radio, and satellite signals can be disrupted, jammed, or unreliable. And in those conditions, manual piloting becomes extremely difficult or impossible. So the Zenadrone platforms are designed to reduce reliance and constant human control by leveraging onboard autonomy, sensor fusion, and mission execution logic. The best example of this approach and the main vehicle that I want to focus on today for you guys is the Zenadrone 1000. This is the best example of our approach, and it is our flagship model. It's a heavy lift, long endurance autonomous UAV designed to support interchangeable payloads depending on the mission needs. So the platform operates in remote, hazardous, and dynamic environments while delivering high precision data with minimal operating burden. It's engineered to support complex, high value missions where reliability and autonomy really matter the most. So the Zenadrone 1000 has a lot of dual use applications. So in commercial environments, the 1000 is used for infrastructure inspection, land surveying, and mapping, all the way to agriculture and utilities monitoring. In defense context, the same platform supports ISR, situational awareness, border and perimeter security, disaster response, and even critical infrastructure protection. The key point here is that the aircraft autonomy stack and sensor architecture remain the same. Only the payload and software configuration change. So beyond the Zenadrone 1000, we also have other models such as the IQ Nano, which is an autonomous drone designed for indoor inspection, inventory management, as well as confined operational environments. We also have the IQ Square. This is an advanced multifunction AI drone that's designed for outdoor commercial applications such as inspections, land surveys, aerial supervision, and security. For defense missions, this would look like inspection and surveillance in the field. Furthermore, the 1000, as I had mentioned before, is our flagship heavy lift mission critical operations. All of these platforms, though, share a common autonomy, sensor, and data backbone. So across agriculture, inventory management, land surveying, infrastructure, inspection, surveillance, ISR, and government defense operations, the same autonomy backbone enables multiple mission profiles. Our shared autonomy, sensor fusion, and data architecture allows organizations to deploy the right drone with the right payload for the right mission without rebuilding the system from scratch. And going a little quicker here for time's sake. So by leveraging the commercially proven technology, government and defense users can reduce costs, accelerate deployment timelines, and lower operational risk. The same autonomy stack that works across sectors, enabling a faster transition from commercial validation to government adoption. And it's a little bit more on that. So what are we looking for? We're interested in connecting with government and defense organizations evaluating autonomous aerial systems, as well as commercial partners with high-value inspection, surveying, and monitoring needs. We're especially interested in pilot programs, evaluations, and real-world deployments where dual-use autonomy can deliver immediate impact. And I just made it in 5 minutes. So thank you guys for your time, and we welcome questions at this time.
Absolutely. Thank you, Sam. All right, feel free to type in whoever's ready first.
What's the max payload weight of the ZD-1000?
Okay, my camera's working now. Sorry about that. The max payload for the 1000 is about 80 kilos right now.
I'll jump in, and this actually ties into a question I see in chat. Where are you sourcing your batteries from currently? There's a lot of language in the FY26 NDAA about, no Chinese batteries effectively.
Yeah, so all our parts are manufactured. Parts, R&D, even down to the drones themselves are all manufactured in the US. So we are currently in the process of getting blue and green UAS certified through AUVSI, but yeah, none of our parts are sourced from China.
Excellent. Thank you.
I have a question. I had some difficulty with my audio. Can you hear me?
Yes.
Yes, I can hear you.
Okay, good. Sorry, I lost track of my thought. I'll be back.
Okay.
Someone asked in the chat if you've engaged or collaborated with the Taiwan ecosystem.
We have in the sense of, I mean, we actually have a facility out there, so we're international as well. But a lot of our agricultural and more commercial projects we offload overseas. That way, we can focus on U.S. defense and operations here. But in Taiwan, I believe we are exploring window washing and all throughout Asia, really, as well as our facility there is the one that's responsible for, I think, microchips and data sets like that. So.
Okay, now I remember. How do you have any government contracts right now with DOW?
So currently we are in the process of a few. We did win a phase 1 SIVR for blood delivery to the battlefield. So our 1000 actually can transport blood thermally controlled in the compartment, payload compartment, to the battlefield as well as medical centers.
Okay, thank you.
No problem.
Where are you in terms of revenues?
I don't have that specific number, I'll be honest. But I will say that we have been publicly traded on the NASDAQ for about 1.5 years now. So
okay, great. Thank you.
No problem.
And then someone else asked, what operating system do you run on currently?
That is all within house as well. Quick background, just to make this quick, we actually started out as a software as a service company. So the software side is also all in-house. So everything is fully integratable with different systems though. So for example, in inventory management, we're able to operate and integrate immediately with whoever's SOP that they're using.
So Sam, let me see if I understand this. So you are pre-programming the mission into your drone, and then you're using LiDAR or and other sensors in effect to successfully carry out that mission. What if the target moves? Because you don't have comms back and forth between your drone and the originating mission center.
Yeah, so there still can be a pilot involved, but we do have onboard AI tech, if you will, to identify the
Yeah.
target. So if it does move, we are able to adjust accordingly through the mission set.
And then how are you communicate? How do you know which sensor are you using to know that the target moved?
Just depends on the build out of the sensor. I think it would be honestly, I would have to ask our technical team to make sure that I have the right one. I don't want to give you the wrong answer, but that's a follow-up question that we could definitely
Okay, no worries.
cover.
I'll reach
Yeah,
out separately.
sounds good. But it is an in-house version of like a Q ground control, if that makes sense. That's what I pulled up here.
Thanks, everybody.
Okay, thank you so much, Sam. It
Thank
looks
you,
like there's
guys.
some other questions in the chat, but feel free to reach out to folks, and we'll connect you with whoever asks for it. And really good presentation. Really appreciate it.
Sounds good. Thank you.
Absolutely. Next up for this session, the last session, we have Lemco. Feel free to start sharing your screen whenever.
Let me get this up. Hang on one second. Where's the share button? There it is. No. There it is. All right. Okay, can you see it?
Yeah, we could see it. Yeah.
All right. All right. Well, thank you. Good afternoon to everybody east of Mississippi, I guess, west of Mississippi. It's still morning. I'm Brian Ponte, Vice President at Lemco. Thank you for your time today and listening to my presentation. Did it switch to the next slide okay? I've had problems in the past with Zoom.
No, it's still on the first slide.
Oh, okay. Let me go back. I'll just do this. Okay, now can you see it?
Yes.
Okay. All right. I don't know why I got to figure that out. But anyways, so yeah, Lemco, we pioneered NFV and mobile edge computing in 5G networks, and we have over 50 patents covering our inventions. We have extensive experience, well over 20 years in both commercial and military sectors, delivering broadband mobile systems. And so when you look at the the battlefield and tactical communications, there's a strong desire, and I know a lot of people are looking at deploying 5G systems in tactical environments. Maintaining the secure, resilient communications, though, is a significant challenge in these environments. These communication systems are vulnerable to disruptions and have multiple points of failures. And communication failures impact the situational awareness and mission success. For mission success, it is critical to maintain access to command, intelligence, and support functions. The what goes on with deploying these 5G networks in tactical situations is they require centralized or cloud-based core network components. So in order to operate these networks, you need to have a backhaul connection Typically, they use satellite to do that, and most of these systems have limited spectrum agility and limited edge autonomy. So what this does is this really weakens the network resilience in these environments due to the single points of failures. And how does Lemco address the problem? Well, our systems, our 5G mobile broadband systems, the core network functions, or as the industry calls it, network functions, virtualization, are fully distributed and can operate independently without a backhaul connection. Each node features on-demand and edge compute, and the system maintains connectivity through spectrum agility and a self-healing topology. And most importantly, when these nodes are connected on a peer-to-peer basis, a comprehensive 5G network is established, providing flexible coverage capabilities, including on-the-move coverage and the ability of the warfighters to move in between nodes in an automatic fashion. So our network functions are fully integrated into each node. And importantly, this includes the database function. This is really a key differentiating point, compared to the rest of the systems that are being used in these applications. And this architecture provides the ultimate level of resilience. In our competitive systems, if the database fails or connection to the database becomes unavailable, the systems become inoperable. In our system, if a node fails, all the other nodes have the complete database capabilities running while they federate together. The database capabilities run on each individual node, so that if one node is knocked out of service, the other nodes continue to operate without any impact from the node that's being lost. Additionally, a big addition to our system is the ability to add a additional radio heads to provide spectrum flexibility. So in the case of jamming the systems, we can move from different frequency bands to keep the system operational. And then the different use cases, we support a variety of use cases in both defense and commercial markets. Our systems, as we're talking about today, are especially well suited for tactical type deployments, not only in defense areas, but also in civil response for any kind of natural disasters, hurricanes, earthquakes. Our systems have been sold around the world for these capabilities, and then also for deployment in critical infrastructure facilities such as nuclear power plants. Again, really, these are locations that really require resiliency and redundancy to stay in operation. So our systems are fully distributed, and our virtualized mobile networks deliver unmatched resiliency, flexibility, and operational simplicity for defense and commercial markets. We're seeking partnerships and connections in the DOW, to explore opportunities to field our equipment and participate in proof of concepts and demonstrations. Thank you for your time. The next slide will be my contact information, and let me know if you have any questions.
Sure. Thank you so much, Brian. So we'll open up the floor. Marissa, go right ahead.
Okay, do your nodes, can they communicate with each other, or are they totally separate?
No, they communicate with each other on what I call the network side, not on the RF side. On the network side, they actually mesh together. And so we have systems that we've deployed which will use satellite as we call it, the backbone, because it's not really a backhaul. We can use broadband tactical radio systems. We can use point-to-point, you know, microwave systems, and that's what provides the ability of the systems to move and the users to move between the systems, because the database on each node communicates with all the other databases on the nodes, and it provides a full mobile capability.
Hey, Brian, are you interested in, I'm assuming that you are high TRL kind of product, you know, you have it. But are you interested in applying to accelerator programs?
Yes, yes, we are.
Okay.
Yes, we think we're in, you know, 8, 9, you know, depending on the use case, seven as low as 7. But I mean, our software is commercial. We field commercial systems. It would be a matter of just doing some of the additional development for some of these more specialized missions.
Okay, so then I recommend trying out Mass Challenge. Mass Challenge currently have an accelerator with Verizon that I think you are perfect for.
Okay, you said Mass Challenge?
Mass Challenge. I can put it in the chat, the
Oh, that'd be great.
website.
Thank you. Yep.
Yeah.
Perfect. I think that's about the time we have for Lemco. Thank you so much, Brian, for presenting.
All right,
And
thank
yeah,
you.
absolutely. And now we are moving on to the second session. So if you were here for the first session, please feel free to stay. If you want to stay on for the second session, happy to have you. If you signed up to be on the second session anyway, also happy to have you. What we're going to quickly do is we're going to do a little bit faster, a quick introduction of the panelists. For those of you who are staying on, I apologize for the repetition, but it's good for the companies and the folks joining to know. So we're just going to quickly go around the room and make sure that everyone is familiar with, you know, who's asking these questions, right? So we're going to start off with Todd. You want to go first?
Yeah, sure. Hey, great to meet everyone. I'm Todd Coulard, a principal at Mark Ventures, where we focus on early stage defense, anywhere from seed to Series A. Right now, we're deploying and fundraising for our second fund.
Awesome. Pleasure to have you. Next up, Samira Curtis.
Hi, everyone. Thanks, Asher, for having me. Yes, Samira Curtis, founder and GP of Rollup Dev Ventures, and focusing on deep tech, frontier tech. A lot of focus on cybersecurity, defense. So happy to be here.
Happy to have you. Next up, Paul Garcia. I know you have bandwidth issues. If you're able to introduce yourself, that's great. If not, totally understand. Give him a second. Okay, I think he's having bandwidth issues, everyone. But he works for the Air Force Office of Energy Assurance.
I try again if they.
Yeah, here you are.
Sorry, Paul Garcia, contract support for the Air Force Office of Energy Assurance. That's installation, energy, anything connected to a utility, both power and water. And we develop resilience solutions across all 200 Air Force bases worldwide. Thank you.
Absolutely. Pleasure to have you. Next up, we have Marissa. Marissa, you want to quickly introduce yourself again?
Hi, Marisa McGinnis, and I'm a full-time investor, and currently I'm looking at, excuse me, healthcare and defense and space startups.
A pleasure to have you. Next up, we have Lucas from Booz Allen.
Hey, everybody. My name is Lucas Snevice. I am an investor with Booz Allen Ventures. I focus on cyber, AI, defense tech, deep tech, and reindustrialization, which you can think of as utilities, energy, infrastructure, and semiconductors, as well as advanced manufacturing. We invest in seed to B companies, check size roughly 5 million, across the US and 5 eyes countries. So Canada, the United Kingdom, Australia, and New Zealand as well. Pleasure to be here. Looking forward to seeing everybody.
Pleasure to have you. Thank you for joining. Next up, we have Bahare.
Hi, everyone. Bahara
Hmm.
Desai, Technology Scouting Director for BAE Systems.
Nice. Happy to have you. Okay. Next up, Katie Vasquez.
Hi, I'm an investor at Calibrate Ventures. We are an early stage deep tech fund, primarily pre-seed seed, doing things across robotics, automation, AI, manufacturing, aerospace, and defense. Typically writing checks anywhere from 1 to 3 million.
Pleasure to have you. Thank you for joining. Next up, Hayendo. You want to go next?
Everyone, great to be here. I'm Hyundo from Honda Accelerator Ventures. We are a CVC arm for Honda Motors. We are focusing on hard tech, deep tech technology across mobility, manufacturing, and robotics. We typically write 1 to 5 million to companies from seed to Series B. Great to be here.
Pleasure to have you. Thank you for joining. And with that, we introduce the panel. We're running 4 minutes early, which is it's good. A little bit of leeway. So we're gonna get started in 0. If you want to start sharing your screen, feel free.
Okay, great. Thank you. Hi, my name is Lou Hughes. I'm CEO of InZero Technologies, and I'm happy to introduce our newest technology called Optica Navi. InZero is a small, privately owned R&D firm in Virginia with 10 employees. Our focus is innovation in edge AI, mobile communications, and computer vision. We also have deep knowledge and skill sets in cybersecurity with 11 US patents in this area. So what kind of problem does Optica Navi solve? The ongoing Russian invasion in the Ukraine has created a dramatic inflection point in modern warfare. Remote command and surveillance, drones and robotics, high precision weaponry, AI assistance are all reality right now. The next step is autonomy. Nobody thinks Terminators are science fiction anymore. Practically all of this equipment heavily relies on radio communication and requires precise positioning data. As countermeasures, radio wave jamming and GPS jamming have become key tactics in modern warfare. The jamming, in fact, around the Ukraine has become so severe, it is even affecting satellites up to 1,200 miles above the Earth's surface. The Russians have also resorted to hybrid warfare. Last September, they actually jammed the GPS of the EU Commission president's plane, forcing her pilots to resort to paper maps to navigate. That's why navigation and positioning in a GPS-denied environment is a key problem to solve. Optica Navi technology now provides the solution: outdoor autonomous optical navigation as a reliable GPS backup. Designed for small and medium-sized drones, Optica Navi is inexpensive with less than $400 in hardware cost. It's lightweight and it can be integrated with any current drone because it emulates the GPS interface. So the drone actually thinks it's talking to a standard GPS module. Using the drone camera video input, the AI on board is able to provide two things. First, absolute positioning data that serves as replacement GPS data. Second, relative positioning data that serves as an additional IMU sensor. The maps of the area can be obtained from available satellite imagery. In current simulations, it's about 100 square kilometers, but can be expanded easily to thousands of kilometers. So what advantages does Optica Navi offer? First, IMU-only navigation technologies cannot reliably solve the navigation problem because of cumulative errors in relative positioning and the challenge of precisely determining the initial position of the drone. Only a combination of absolute and relative positioning works in practice. Second, radio beacon navigation technologies, which by the way are used to find your phone location using cell towers, ultimately use the same radio waves and can eventually be jammed. Optica Navi doesn't rely on radio and therefore cannot be jammed. And since it operates autonomously and requires no external connections, the drone can now operate in radio silence, reducing the risk of detection. Optica Navi also doesn't require recent satellite imagery. In most cases, Google Maps will suffice. If absolute positioning cannot be found for some reason, Optica Navi automatically switches to relative positioning. This ensures continuous positioning data are delivered to the drone flight controller. Finally, Optica Navi's weight and size make it perfect for integration into any drone, civilian or military, providing a backup system in case GPS signal is lost. This capacity is not limited to drones. Any helicopter or aircraft could benefit from Optica Navi. Our team participated in the X-Tech sponsored drone dominance competition a couple of months ago, and we were selected as a finalist from more than 100 submissions. Our current development status is TRL4. We have a working and flying drone prototype with relative positioning implemented and tested without GPS. Our absolute positioning is working in simulations and available for demonstration as well. Our target is to finalize and field test the technology in 8 to 14 months. We are actively seeking government and private funding to advance our technology to TRL7 and begin commercialization. We welcome client engagements, strategic partnerships, and approximately $2 million in additional funding. Thank you. Alex, maybe, I'm not sure, for some reason, I've had difficulty getting in myself under my name.
So
Alexa, if you
I
close, if
provided
you
him
stop the
link.
screen
Yeah.
sharing, maybe it'll revert to me.
I could. There's a little rename
Are
button
there,
if you guys want.
yeah, let's see if, can you guys see me?
Yep, we can see you and
Okay,
hear
great.
you.
Very good. Great. Perfect. That's good. Okay, so I'm here. Fire away.
Was someone asking a question? If so, go right ahead. All right, I have a question in the chat. Someone asked, how does it work in a dark environment?
So right now it actually doesn't, because you need to adapt and use the thermal vision or night vision cameras. So basically, next stage, and we had it in the presentation, we will train our AI to work with night vision. But basically, like there is no obstacles why it will not be working during night.
Got it. Sure.
Question for you. So you guys are saying that you're operating in GPS denied. So have you tested your equipment with the GPS on to establish where the drone is and then deny, or are you only using relative?
So basically, current prototype has several modes programmed. One is programmed using like hybrid mode, where GPS is locked and we are flying using relative positioning. And then we compare results and see, okay, how much cumulative errors we got actually on the system. And the same thing goes into the simulation. So we have a simulated state where we know the position of the drone itself, and we using our AI, we are determining and recognizing the position. In this case, the input goes through from the camera, emulated camera. We are using like Bing maps as an input, and while AI was trained on Google Maps, so AI actually didn't see the pictures what it's fed on.
Got it. And my follow-up question looks like somebody asked it in the chat. Have you guys done any work in the maritime environment?
No, not yet.
Got it.
Cool. I think we have time for one more question if anyone wants to ask. Oh, it looks like there are. What are the advantages compared to other autonomous navigation systems? Someone asked.
So basically, if you compare us with other like vision positioning systems, Vermeer, for example, they are relying on the video footage that was like taken previously, and they are building their maps using this video footage. We are relying on satellite imagery, which is like easily obtainable, and actually elevation data, which is also the like practically public information, and we can build our maps using this data. So you can plan your route for thousands of kilometers without flying first and doing reconnaissance.
What this is my own question, but what happens when there's weather effects? Like, let's say you have satellite data that was on a non-snowy day, then all of a sudden there's 2 feet of snow. Will it still be able to navigate?
So basically, relative positioning will work as intended. The absolute positioning, okay, it will have gaps in providing absolute positioning data where you have like, okay, white plane where you don't see anything, but eventually you still have recognizable parts of the environment that AI will grab on and provide absolute position, and you will be back on route.
Okay, that makes sense. There's another question in the chat that I'll just ask for them. Someone asked how large is the drone, which I don't know if that's relevant, and what location precision are you achieving? What is the altitude necessary, if there is one?
So in current simulations, we have like reliable absolute positioning at the altitude of 150 meters. We can easily expand it higher into the kilometers, like 1.5 kilometers could be achieved easily. When you're going down, we also have planned switching from to the wide lens cameras, where you can actually look not only like down to the what underneath you, but to the sides to provide more data to AI, which will increase the altitude, decrease the altitude from 150 meters to 30 to 40 meters, somewhere in this range. The accuracy at the 150 meters altitude is within 2 meters.
Sure. Okay. I think that's the time we have. I really appreciate it, both Lou and Alexi. There is one more question in the chat if you guys want to answer them. Um, but thank you so much for the presentation. And feel free to
Thank
leave
you.
your contact information.
Okay, will do. Thank you.
Perfect. Next up, we have ThruWave. If you guys want to start presenting, feel free.
Hi, yeah, sure. I'll share my screen. Can everyone see that okay?
Yep.
Great. Okay, well, thank you so much for having me. My name is Claire Watts. I am one of the co-founders and the CEO of ThruWave, and I'm here today to talk to you about our millimeter wave imaging and automated detection solution. Before I get into the actual tech, I want to discuss a key feature trade-off when we're talking about current sensing and detection solutions on the market today. And on one end of the spectrum, you have, traditional cameras. They are fast, they are cheap, they are automated, but they lack the ability to see inside opaque packaging and containers. So they're really only giving you a small part of the data set. On the other end of the spectrum, you have solutions like X-ray, CT, trace analysis. And while those can augment what a traditional camera sees, they are not scalable for operational environments. So really the need here is a solution that can provide visibility beyond a traditional camera, but the scalability to operate in high volume operational environments. And that's exactly what ThruWave has created. We are selling scalable see inside screening solutions that can address problems in national security and supply chain. Our solution is high speed and high throughput. We give our customers and end users the ability to audit and screen 100% of packages, parcels, and boxes moving through their facilities, even in high volume environments. We use patented millimeter wave sensors that, unlike a normal camera, can see inside a box, but unlike something like an X-ray system, do this in a completely human-safe way. We layer this with AI-powered automated detection, meaning our algorithms find anomalies automatically without the need for a human decision maker, and we package this all in a low-cost, scalable solution. So in terms of how it works, it starts with a scan. And what I mean when I say that is items of interest move past our patented sensor hardware. As they're doing that, we create a 3D image of that item. Because we're using millimeter waves, we get an image of not only the exterior, but the contents as well. We then analyze that image with one of our proprietary or patented algorithms to essentially find items or anomalies that are of interest to our customers and end users. The final step is when we find those items, we can flag them or divert them or somehow remove them from the workflow so our customers can inspect them with a secondary method. And we do this entire pipeline very, very quickly at high conveyor speeds and volumes. So getting into our applications, our core imaging unit has been proven to be very robust in a lot of operational environments. And we can tune the automated algorithm piece to meet the needs of various customers and end users, ranging from mail and cargo security to supply chain quality control. We're actually spinning up a few new applications that address detection of dangerous goods like lithium-ion batteries, as well as detection of hidden explosives like IEDs and IIDs. And in addition, we're happy to discuss new and exciting use cases that can provide value to customer workflows. But diving a little deeper into our mail and cargo security application. So the use case here is to audit mail and parcels for illegal and dangerous items being trafficked through legitimate mail channels. This is a project that we started with US Customs and Border Protection. We've actually developed a proprietary algorithm that can detect specifically narcotics and firearms and tobacco, but this is just as useful for physical security and chain of custody integrity in US government and military facilities as well. Here's a quick video of one of our mail inspection solutions. You can see it's kicking out an item that is flagged, and items that are deemed good or non-anomalous will continue throughout the mail stream. So switching over to one of our more mature applications, the supply chain quality control side. So here we're auditing more for safety and quality concerns like count mismatch, damages, leaks, all inside boxes, containers, and totes. We've done several projects and pilots with some of the largest private sector e-commerce companies in the world, but this is just as useful and applicable in military logistics and for defense contractors. So now that I framed kind of the context of what ThruWave does, I want to get to the ask of why I wanted to join today. I think first and foremost, we would love to connect with potential government and private sector customers, basically organizations that want to leverage novel sensing technologies to address some of these security, quality control, safety issues that they have in their workflows. In addition, we would love to connect to strategic partners, both those who can help fund and collaborate with us on research and development projects, specifically in light of these new applications for dangerous goods and explosive detection, and also strategic partners that can provide system integration, resale, channel partnership, et cetera. And then finally, we'd love to connect to those in the venture capital space, especially as we strategize about our next external fundraise. So I'll just finish up with a little bit about who ThruWave is as a company. We're a Seattle-based startup. We were spun out of the University of Washington. Our technology is based on years of research and lots of patents in the millimeter wave imaging space. We have a dynamic team filled with a lot of subject matter experts in this space, including 6 PhDs, 4 team members from our original UW lab. I'm probably over time, but just thank you so much, everyone, for listening. Happy to field any questions or comments from the panel.
Sure. Thank you so much, Claire. Feel free to go ahead, whoever wants to ask first. Otherwise, I have quite a few questions myself.
Sarah Jones from In-Q-Tel. So I had a question about, does the sensing, the millimeter wave sensing technology, could it accommodate a swap that was portable?
Yes, so that's a great question. While we haven't developed it yet, our core module is about the size of a brick. And so we can tile it to fit kind of any geometry we want. And we've done quite a bit of work researching what it would take to make a handheld portable unit. And we find that that's totally possible. We've actually made some early prototypes that run completely on a battery.
Great.
So I had a question. I'm going to go right ahead. What kind of IE? Because the whole name IED implies improvised, right? So I'm assuming that the detection of IEDs would be relatively complicated. And then just to go rapid fire, because I had another question. Have you ever checked your statistics? Because I always read these articles about, airports failing routine checks where they, put a fake whatever in a suitcase and see if it gets through or not. And like, have you guys ever run any statistics against, human checkers?
So I'll start with the first question because you're exactly right. And you'll notice that the TRLs of those detection algorithms was pretty early. And so we believe that we'll use likely a multimodal sensor modality there. Kind of our thought is X-ray and trace is not enough. We should leverage also millimeter wave technology to kind of create a more complete sensing modality. So that gets into the complexity of it. And we've already talked to some X-ray companies, but you're exactly right. It's probably going to be a combination of chemical detection and kind of spatial pattern recognition. For your second question, we're always running, we take our performance very, very seriously. We are operating in real world mail inspection facilities. So we're working with CBP to define these performance metrics in situ. I will say there's nothing that comes to mind in terms of kind of testing ourselves. We're always running again, performance statistics. I'm trying to think of something we did catch. It was concealed, I believe, inside a picture frame, but we'd always try to keep track of kind of the ways that these bad actors are concealing and bringing in these items into the country.
Sure.
And this is Winnie from Ajinomoto. Just a follow-up question, building on what Asher asked. What is the potential or challenges to combine millimeter wave with terahertz to provide that kind of improved resolution in these kind of critical applications?
Yeah, so I will say one of the ways that we find we can streamline that is our architecture and pipeline is very modular, and so the algorithms themselves can easily bring in other sensor modalities. I would say the challenges when you're talking about bringing in other sensors such as terahertz and X-ray is making sure they can keep up with the speed at which we are able to generate images. That is one thing that sets our sensor solution apart. It is our patented technology. We can screen items moving at up to 600 feet per minute on conveyor belts. And so we'll likely have to leverage some new additional technology to make sure that X-ray systems can screen kind of at speeds that match our speed. Did that answer your question, Winnie?
Yeah, thank you.
We have time for one more. Marissa, go right ahead. Last question.
Who owns the patents? So do you have a license from the University of Washington?
Yeah, great question. So it's a combination of patents that we have an exclusive license for from UW, and then we do have ThruWave owned patents as well. The UW license are more geared towards the core hardware and software, and the ThruWave patents are more geared towards the applications and analysis algorithms.
Thank you.
Thank you so much, Claire, for the presentation. I'm sure you should, if you're willing to, leave your contact information in the chat. I'm sure there will be some folks who are interested in connecting. Next up, we have Pylum, and I think Jose will be presenting.
Hi, guys. Good to see you. I'll go ahead and share my screen here. All right. Can everyone see that all right?
Yep.
Awesome. Well, Pylum is a company that Dean and I co-founder. He's also on this call. So in the Q&A, if you guys have especially more detailed technical questions, he's free to answer. We're building combat-proven drones. Over the last 2.5 years, then I've been working directly with Ukraine, multiple units across Donetsk, in building out and iterating with fast iteration cycles drones that have taken down tanks, supply depots, and proven to be very successful. So I'd like to open up with some video from our drones on the field. Here, one of our drones is approaching a target. And we had another ISR drone that captured it. Each one carries 3 to 4 kilogram payload. And in this mission, it was able to disable an armored vehicle. We've had 68% mission success. And as you can see here, it really just takes one well-placed drone to take out a tank. That drone cost us about $900 to build. And I can't give you the exact cost on that tank, but it was likely more than $900. See, the big shift we've seen in warfare is going from this era of tanks and rocket launchers to this era of $800 drones instead of $100,000 missiles, and doing the work of a $100,000 missile. But at the end of the day, these drones are hobby toys. They were a last minute adaptation that was very clever and has worked well, but the era of FPVs are coming to an end. And so at Pylum, we're leveraging all our experience with FPV drones and with American manufacturing, even the chips we've made in the US, to transition into the new era of warfare. Right now, there's slow-moving contractors, and some of you with military experience will understand this. It can take years through multiple R&D cycles, testing in the deserts of Nevada, just to come up with a product that eventually might make it to the battlefield, only to find out it's actually not so suited for that battlefield because they took so long to test it in a real scenario. We don't have that issue. We work like a software startup with drones because we're directly affiliated with units on the ground. Every week, we're testing new products, new versions of the product. And then, of course, there's the foreign supply chain issue. China owns 89% of drone market share. You guys are all very familiar with how many drones China is able to produce and how much of our supply chain in all kinds of military defense relies on China. We're ending that. Our drones are American made down to the frame and the chip. So here's our solution, what we're working on next. This drone, you can imagine it about the size of a 2-liter Pepsi bottle. It has a jet turbine inside of it. Most drones that you see on the battlefield, like the videos I showed you of ours, are only capable of going about 100 miles an hour. And they can be very accurate, but ultimately their altitude is constricted and they're all in this contested airspace where they can be shot out of the sky, easily jammed, where you need FPV goggles and one person operating one drone. It's not scalable. So what we created is a drone that can go 500 miles an hour, 40-kilometer range, 4-kilogram payload, and reach 10,000 feet in altitude. This acts in a very similar way to the video that you saw of that drone, just 5 times faster and much more stealthy. It's able to operate in areas where it won't be jammed, and it has an onboard compute system that Dean developed himself that is able to auto-target going at these speeds. And so all the compute needed to allow this drone to operate autonomously is on board. This also allows for frequency hopping, so it's less likely to get jammed, and swarmware. It allows it to communicate with other drones to hit a target from multiple sides or hit multiple targets in a concentrated area, all while only one operator is using it. It's much more scalable. So like I said, combat proven, over 29 months, we've been doing this, and we've seen our hit rate go up substantially. We've already secured interest from different NATO partners and eliminated many high-value targets. The market opportunity, of course, is huge, right? Over the next 5 years, it's projected to reach about $147 billion. Everyone has seen what's happened in Ukraine and recognizes the need to switch to cost-effective, mass-producible drones that most of all are made in NATO territory. Our business model is a combination of government contracts, military unit partnerships. This means working directly with military units who have their own funding, and a software platform. This is what allows for the auto targeting for the swarmware, and the upkeep on this, we can charge about $1 to $3K a month. It only costs us about $3,000 to $4,000 to build, and we plan on selling them for about $20,000 to $30,000 a unit. These are essentially guided missiles, autonomous guided missiles that we can mass produce for just $20,000 a unit. Now, our team is spectacular. Dean has over 15 years in hardware and software engineering. He worked in aerospace and defense, R&D, NASA, MIT. He was the VP of a large drone company in China, lived in China for a number of years and speaks Chinese. Myself, I founded another company, Helios. We build modular data centers for AI compute. I also founded the Eden Foundation. It's a humanitarian organization, handles logistics for Ukraine. Spent years in the energy industry and was a quant at a hedge fund. And then our third member, he has to remain anonymous. He has some confidentiality constraints with his current employer, but he'll be joining full time in a couple months here. And he has over 30 years experience in exactly this. He's the one who worked on the frame and the aerodynamics of the system. And so we're raising 3.2 million. In over 12 months, we plan to get to about 3 million in contracted revenue, 5 repeat buyers, ramp up to about 300 drones a month, and have over 500 drones deployed in active combat. So we'd love for you guys to join us. It's a $3.2 million seed round. We were able to prove ourselves out in combat through donations. We've received over $200,000 in donations over the past few years. That has allowed us to build this product out and test it with soldiers on the ground. That's us. That's Pylon. Thank you.
Absolutely. Marissa, you go first.
Okay, where are the drones manufactured?
In Utah and Colorado. The chips are made in Colorado and the rest is made in Utah. And that's where we're based. We're based out of Salt Lake City.
Okay. And then tell me about the chips. So are they proprietary? You're making the chips or you're sourcing them from someone?
Yeah, so the board as a whole consists of flight controller, a chip that we take from NVIDIA's architecture that allows for really fast onboard AI processing. And then the chip as a whole is something that Dean created.
Thank you.
Hi, Jose. How much did you say per unit it's cost for the platform?
So for us, it costs us about $3,000 to $4,000 to build this new drone. Our old drone, which we're still producing with donations, is only about $800 a drone. However, this new one, of course, much more capable. And then what we plan on selling that for?
Yeah.
About 20 to 30,000 per unit.
Okay.
Now that being said, that's of course up in the air, but right now we're bidding for a few contracts.
Okay. Thank you.
Hi, Jose. How are you?
Hey, Samira.
Yeah. So is this also integrating with the military C2 platform?
With a what platform?
military C2 platform is the drones. Yeah.
That's right.
Okay.
There's one question in the chat, if there's no one who wants to ask one live, but they asked about, you know, how will it manufacture at scale and can it be decentralized?
Yes, so that's something we've experimented quite a bit. Everything from building out kits and then shipping them to Ukraine for final assembly. That makes shipping easier, and we have a lot of experience in the logistics of that. All the way to building out the full product here and sending it there simply for armament, right? The actual explosive payload. That's what they do in Ukraine. Um, Now, to manufacture these, it's relatively simple. And so we're able to set up shops in US, in Ukraine, parts of Europe, etc. Right now, we have the manufacturing capability of about 50 to 100 drones, these new drones, a month. Now, of course, with this funding, we'll be able to scale up to 3 to 500.
Sure. And someone else asked in the chat is if there's ITAR considerations that need to be had based off of the design or the components.
Yes, so in the future, that will become more relevant. One way we've been able to get past the hurdle of the red tape of this industry is in simply creating a drone, right? This does not have any explosive attached to it. All that is done in Ukraine, and we make it very easy for them to do. But so far as anybody in the US is concerned, anybody could buy this.
Sure. We have time for one last question from the panel if someone wants to go ahead and take the last question. Otherwise.
Yeah, can you talk about how many you lost?
Sure. So let's go back to the stats here. So of these 220 successful missions, that's been at a 68% success rate. So we've had a total of 300 something drones that we've flown, and 220 of them have hit their target. Now, a success means that every time they're flown, they're lost, right? They explode upon contact.
Yeah, I guess my question was, can you just talk more to the why behind those that weren't successful?
Sure. Either they get jammed, and they get jammed in a way that either we lose sight is the easiest way a drone can be jammed, or they actually jam the controls. When that happens, then they can easily be disabled. So that's a big reason why we developed this drone that has all its directional capabilities on board.
Sorry, I don't mean to keep hogging and
No,
asking.
no, that's all right.
Are you building that into the pricing model?
We are, yeah. So the pricing model includes some base cost per unit for the drone, and then a software platform on top of that.
Cool. Cool. Thank you so much, Jose. I think there are more questions in the chat even. There's like at least one more question in the chat, so feel free. I see you have your contact info. That's awesome. And so, yeah, feel free to answer those questions individually. Next, we have Absentia Technologies.
All right, can everyone hear me?
Yep, loud and clear.
All right, good. Let me just share my screen. All right, can everyone see?
Not yet. It's a black screen for me. I don't know if I'm just lagging.
Yeah, black screen over here too.
Can you try to reshare maybe?
Yeah, I'll try it. Can you see now? Or is it still black screen?
It's a black screen.
Hmm. In one moment.
Still black. Maybe we could share it on our end.
Okay. Um,
I think Brent's pulling it up now. We'll see if he gets a black
okay.
screen too. There it is.
All right, nice. I'll just let you know when to change the slide, I guess. All right. Just to begin, the Special Forces unit on a midnight raid, relying on drone feed to monitor threats. Suddenly, fog rolls in, or an enemy jammer scrambles a video. Their eyes in the sky go dark. In that moment of blindness, the unit is exposed. This isn't hypothetical. It's happened on battlefields where troops lost sight of targets and paid the price. In subway station during rush hour, a fire breaks out and fills the platform with smoke. Within seconds, hundreds of cameras are useless, security teams are blind, people are running, some injured, some trapped. The vision systems failed exactly when visibility mattered the most. Two incidents, and both the warning signs were visible, the systems just couldn't see. That failure isn't anecdotal. It's a missing layer in global infrastructure. That's why we founded Absentia. ISR missions lose 30 to 40% of effectiveness due to vision failures, costing DLW billions annually and risking lives. 75% of remote sensing imagery is lost or devalued due to fog, haze, darkness, and glare. Hardware can't fix this. Satellites and drones already deployed can't be upgraded mid-mission. Current AI is too slow for edge compute and lacks the autonomy to adapt in real time, and data from radar, optics, and telemetry stays siloed, too fragmented for time-critical decisions. Absentia fixes the input layer. We make degraded data clear before it reaches your fusion stack. You can change the slide. We built 5 AI agents for every type of visual noise. Ghost clears fog, Spectre amplifies darkness, Spirit stabilizes and deblurs, Shade removes glare, Phantom detects and tracks through clutter. They're all coordinated by Mystic, our LLM-based command interface. An operator says enhance the northeast feed, highlight weapons, and the right agents fire instantly, in real time. We deploy via desktop client, terminal for edge environments, or API for existing C2 systems, and currently reach an average of 30% increased clarity. We don't hallucinate, we don't invent pixels, we reveal the truth hidden in the blur. Change slide again. Defense and aerospace vision is a $75 billion market by 2030. AI-powered systems for ISR, targeting, and autonomy in GPS-denied, EW-heavy, and low-visibility environments. Commercial security is $148 billion. Enhanced surveillance, multi-feed analysis, and anomaly detection for critical infrastructure and public safety. We have clear entry points in both. You can change the slide again. Absentia is the only AI company solely focused on enhancing degraded video in prohibitive environments. Palantir and Enderal build fusion systems, but they need clear data to start. We make it clear. FLIR and L3Harris build optics, but they can't retrofit mid-mission. Our AI can. In the commercial space, Flock Safety needs clear weather to operate. We give you the whole picture when conditions go dark. We don't compete with them, we complete them. You can change the slide again. We have built 5 AI agents in Mystic in-house, and it's operational. We're endorsed by Tier 1 SOF leadership. We have 2 customers onboarding, a NERPS 2025 Spotlight, a Fujitsu partnership in progress, interest from the Port of Tacoma Commissioner, and a DOW pilot program invitation pending. With this round, we're launching pilots targeting 75% clarity improvement in degraded conditions and transitioning from validation to operational deployment. Next slide. We're raising a $1.3 million safe at a $16 million post-money valuation. The capital goes towards GPU infrastructure, engineering hires, data acquisition, and pilot operations. This gets us through validation and into multi-million-dollar contracts in 2026, paving the way for a much larger price round partway through the year. Next slide. 4 months to seed. First, we build out infrastructure and bring on key hires. Then we refine our models and start NIST 800-171 and DOW compliance groundwork. Month 3, we go live with pilots. Month 4, we finalize compliance and then transition to seed. Next slide. Our leadership team brings defense and commercial experience. I'm Andrew Ferguson, CEO. My co-founder Emmanuel Angeloff built the Morpheus Space brand. Tony Melendez is a decorated Army veteran who did sensor fusion at Raytheon and now serves as head of development. Houston Hamilton brings Army OPSEC and PsyOps experience and leads our compliance and DoW procurement strategy. Brandon Bagwell is our head of sales with 10 years in tech sales. Next slide. Behind them, we have PhD level machine learning engineers, a full stack developer from Google Gemini, and a Navy veteran leading IT security and with DoW compliance experience. You can go to the next slide. Here's just some citations on the numbers we used throughout the pitch. Next slide after that. The world built billions of sensors. Now it needs intelligence to make them see. No one should ever say again, we couldn't see. Thank you.
Perfect. Opening the floor for questions. I can go first, I guess. Can you talk a little bit more about TRL level?
Yeah, so within the we've already tested our software within the commercial space. So I would estimate ourselves to be around a TRL5 within that space.
Sure.
If in terms of DoD or DoW, we are still sorting out compliance, and a big thing with this round that we're currently within going through is to really help finalize all of that so that we can make our entry within the DoW market as quick as possible.
Sure. And then for the commercial use case, it's mostly for, I guess, cargo, right? It would mostly be...
Yeah, so we've a lot of interest has been within the security space, although really
Sure.
in the commercial space, the approach to development we're taking is really in any situation where visibility matters, our software can be deployed in that environment. Though given the limited resources of a startup environment, our initial focus is on security. One of the biggest points of interest, which I noted within the pitch, was the port commissioner of the Port of Tacoma, and they've had, as you can imagine, with the port, they have frequent issues with bad weather and fog, and they had an issue pretty recently of like severe damage to one of their ferries due to it hitting a log that it wasn't able to see due to heavy fog. And yeah, and then if we can go forward with them, they're, like I said, they're very interested. Their contract could potentially be a multi-million-dollar contract based on their pricing model.
Sure. Oh, and there's a question in the chat. How quickly is the response time from image to increased clarity?
Yeah, so we average around like a 50 ms latency, and we can operate at approximately 30 FPS at the moment. We're hoping to speed that up through we're currently doing heavy maintenance on our back end, which will hopefully speed that up to an average of 60 FPS.
Yeah, we have time for one or two more questions. I could read more of the chat questions, but obviously live ones are good too. All right, I'll keep going until someone chimes in. Someone, the same person asked if you've been working with fire departments, especially in the Seattle area.
That's definitely something we want to work with. One of the things that was noted by two of our other customers is that one of the big things that is essentially in demand is things like Firewatch and the ability to go and detect fires as they occur and do things like clear up the smoke and then pinpoint the source of the fire, pinpoint any people trapped within a fire. So that's absolutely something that we plan to begin approaching pretty soon.
No, that makes a lot of sense. And yeah, that the use case of having it in combat zones, having issues with fog and weather is yeah, that's definitely. I'm sure the DOW would be very interested in that. Cool. Thank you so much for the presentation, Andrew.
You're welcome.
Yeah, absolutely. So next up we have Navier, and I think Evan will be presenting.
Yep. Pulling up the screen here. Sweet. Let me know if there are any issues seeing it, but otherwise we'll dive.
You're good.
Cool. Otherwise, we'll dive right in. I'm Evan, one of the founders of Navia AI. Navia AI is building an agent-driven engineering platform. So a little bit about us. We're a team of about 10 right now, all based in San Francisco, California. And every single person on our team comes from deep technical background and has approximately built and launched land, sea, air, and space vehicles. And so what that means is we've worked at companies like SpaceX, Tesla, General Atomics, NASA, and fought the engineering tools that everyone uses today, from the CAD to the simulation side of things. You would expect that all of these are closed loop and extremely powerful, but today, a lot of the tools lack taking advantage of all of the advances around AI and ML. And so we built Navia AI to rethink the engineering software stack and redefine how hardware can be built on a day-to-day basis, enabling small teams to do more. And so when you talk about our actual kind of platform and what it does, Navia is building the autonomous engineering platform. You used to require hundreds, if not thousands, of engineers to work together across disciplines to use those complex softwares to iterate through designs. We're training and developing and building AI agents to automate each part of these explicit engineering disciplines such that they can go iterate overnight, build these complex designs, simulate their performance, and deliver hardware at an unprecedented rate. And so what that actually looks like from a product perspective is we have specialized agents that dominate a specific engineering discipline. To date, we have two core products, one being Stella, which is our GNC and mission planning agent, as well as Stokes, which is our CFD simulation agent. We've been targeting the aerospace and defense industry as new missiles, new aircrafts, new vehicle platforms need to be developed extremely quickly to deliver in the intense global market that we're seeing today. Ultimately, we'll expand these out to custom integrations, custom softwares, custom workflows, but we're building out the core engineering suite and simulation package that enables teams to deliver faster. To put that into perspective, our platform looks something like this on the right-hand side for computational fluid dynamics. Let's say we take an input geometry and you need to assess the product's performance before you go build it. Our agent interacts with 3D geometries, understands what they are, where they are in 3D space, comes up with an engineering task list, and then goes and performs all of those operations within 3D space. So instead of an engineer or multiple engineers sitting, doing point and click, or pointing and doing mouse clicks, or waiting for files to download or monitoring things, our agents perform all of these tasks end to end. For some engineers, that's saving them up to 4 hours a day on just setting up and post-processing. On others, it's empowering engineers to do 3x the throughput that they typically would have. So you can imagine the software being the cursor for true engineering software and engineering tools. And this is applied to every single organization that's building hardware today. And so we can see our agent kind of build this whole simulation end to end, and we deploy that directly within our HPC infrastructure, allowing engineers to go look at results and do the actual engineering versus doing the brainless, mindless types of activities that they typically spend time doing. We're taking the same agentic tech stack and applying it to other parts of the engineering process, which is where Stella comes into play. Stella is an integrated GNC and flight software development platform where an AI agent can take in mission requirements and maybe simulation outputs from Stokes and develop an entire flight code written purely in Rust, as well as set up the simulation and run all of that end to end. And so what that means is you're taking both the GNC team as well as the flight software team, integrating that into a single platform, having an agent automate the entire setup, running the simulation, and outputting and reporting steps, and allowing an engineer to get from 0 to 1 in minutes rather than days across dozens of engineers. And so as we build out these capabilities, more and more of these agents will work together just as if engineering teams do, and we'll ultimately be able to build a suite of agents that design kind of a drone or a satellite end to end. How we typically work with customers is threefold. One, we have our actual platform, which is broadly available for specific public-facing products, so Stokes and Stella at this point. That is a typical kind of SaaS deployment. We built out the entire cloud infrastructure and own everything end to end such that you can run these compute-intensive tasks. But we also have a desktop app and can deploy locally for the defense-focused folks that require all data to be siloed within their firewall. Apart from that, we do custom agent development. As we see with a lot of aerospace companies, a lot of workflows are proprietary to them or specialized to their specific needs, in which we come in, take our same agentic tech stack, build out the agentic workflow that they have, and automate their pain points. So what this means is still a single one interface platform but allowing them to access both our solvers as well as solve their specific automation pain points across the board. And then ultimately, we will provide forward deployed engineering support to ensure they get the success that they want. And so what that means is we have engineers on staff that go sit alongside our customers to understand their pain points and make sure our software is integrated into their workflows and we deliver the true agentic automation that they believed in. And so across all of these, we already see them deployed at aerospace and defense companies, both at the early stage as well as mid to later stage, and are continuing to grow out our capabilities across market verticals as well as across different physics solvers. And with that, that's Navia AI.
Awesome. Thank you so much, Evan. So we'll open up the floor.
Hi, Evan. Thank you for your presentation. I am a little bit worried about the trust. What are engineers saying about this? Are they trusting it?
We completely agree with that as well. And so let me just jump forward here. Cool. I'll pause this. Trust is extremely important, and there's two ways we face that. One is whenever you run a traditional numerical simulation, you can validate it against experimental data. So one thing we've done is run a fluid dynamics simulation in our platform and validated it to commercially relevant experimental cases to show that the actual underlying solver is correct. And then the second piece of it is we firmly believe engineers need to remain in the loop. And so we provide the explicit workflow calls within the process that an engineer can go in and audit, look at, and update after the fact. And so can't necessarily zoom in here, but while this demo kind of just shows an initial setup, we have a whole kind of advanced version of the platform where you can go into every single specific setting and let an engineer determine what setting was made, how it was made, and if it is the actual right setting before they go kick off some of these simulations. So everything is fully auditable by engineers.
Thank you. I'd like to connect with you after this.
Yeah, sounds great. I'll ping you in the Zoom chat. Any other questions?
Yeah, let me just
I
check
cannot see the Zoom chat, sorry.
Yeah, I can see it. I don't think there's necessarily questions in the chat as of now. Would you mind, I mean, just for my sake, would you mind going over some of the like use cases in terms of, the fluid dynamics? So for some of the folks who are less initiated, let's say.
Yeah, definitely. So a lot of people overlook fluid dynamics, but it's used in essentially every single physical product that's built to date. And so one thing that's often overlooked is air is technically a fluid, and so aerodynamics is massive. That's everything from really driving the performance of electric vehicles in range. So we use CFD simulations to evaluate the overall drag, which is used to protect range. For every aircraft or missile, you use aerodynamics to evaluate performance. So how fast it goes, whether it heats up too quickly, and how to control it to ensure it hits the target and delivers the results you need it to, all the way into energy generation, wind turbines, or massive CFD users to ensure you can inch out every % of a performance improvement to essentially generate those small microgrids. And then even into more of the thermodynamics applications. So AI and data centers are super hot right now, in which you can run fluid dynamics simulations to estimate how you cool the chips. That could be air flowing over NVIDIA GPUs or water cooling loops, looking at thermodynamics around an entire data center. So truly every single hardware product built to date leverages in CFD in one way or another. But I guess taking a step back, they use simulation in one way or another. So a lot of the times that's CFD. Sometimes they do structural analysis, which is coming soon. And we're building out the capabilities to really touch every single physical product that exists in the world today.
Sure. That makes sense. And then there's one question in the chat. How useful is it for reverse engineering?
Great question. There's different ways that I think I would tackle this. While we focused on the simulation side, one thing we spent time experimenting with is how this can be performed or applied to the design side. So allowing an agent to go develop parameterized models. And so there are probably ways where, given some set of target requirements, you can build an agentic loop to say, run this simulation, it missed a performance target, update this design, and kind of iteratively do that until you come up with something similar. Or if you have a reference design that you're looking at and you want an agent to take maybe a handful of images and attempt to develop a 3D model, that's something we're exploring in the future as well.
Sure. That's awesome. Well, perfect. Thank you so much, Evan, for the presentation. It was really interesting, and there's a lot of interesting use cases. It seems like for this, so excited to see where it goes. And feel free to leave your contact information wherever you choose to leave it in the chat or however you want to do it.
Cool.
Pleasure to have
Will
you.
do. Thanks, everyone. Bye.
Yep, absolutely. Next up, we have Bullseye. I hope I'm pronouncing that right. I think I am. Or Bullseye. Yeah.
Hi, Casher. All right. I'm sharing my screen now. Let me know. I think you should be able to see it.
We see
So,
it.
I'm the founder and CEO of Bullseye. We're trying to enable designless semiconductors. What that means is that we're trying to enable companies that are developing embedded software to get the benefits of custom ASICs without having to have an in-house chip design team. And ASICs are important. All the big players nowadays are manufacturing their own ASICs, and to them, it's no longer just a product to sell. It's a competitive feature. As in, you hear from Sennheiser engineers, it is really hard to compete with Apple because Apple is able to do hardware software co-design. Now, the big players are able to make their own chips, but it costs a lot of money. So there's kind of a cutoff for where it makes sense in terms of volume and in terms of company size. So what does everyone else do? Well, if you're building, let's say, automotive or drones, you go to one of your suppliers and buy an off-the-shelf chip that comes with a lot of bells and whistles. This is not the best chip for you. This is kind of the most okayest chip for the widest possible audience. It will come with some CPUs, some graphics units, some neural network units, cryptography, and so on. And then it's your job to lock yourself into the vendor's ecosystem. Right, to port your code to their chip. What we're trying to enable you to do is to get all the benefits of a custom ASIC without having to develop that custom ASIC or without having to use someone else's chip. And we're doing that by basically allowing you to use FPGAs, a class of post-fabrication rewirable chips that require you to still develop chip designs. But what we're doing is allowing software engineers to use them without doing any rewriting of their code. So really, what we're doing is 100xing the number of folks that can target FPGAs and deploy them on edge devices, right? And this idea that you're going to take code and arrive at a chip design is not new. It's been around since the 80s. A lot of tools have been written, but it has been kind of an academic tar pit because most of these tools require you to, again, lock yourself into some specific language, like anything from OCaml to Haskell, right? We're taking a different approach, and we're saying that, hey, your software is just a black box to us that takes in some inputs and produces some outputs. And we're going to look at behavior, anything from sensors coming in and how your software controls, let's say, motors. And what we're doing to get a chip design is that we're going to train an ML model, a very specific kind of neural networks we have developed that we're training to become a digital twin of your software. And we have a way to convert that neural network into actual digital logic. Neurons become gates, weights become wires, and you get a chip design that you can run through existing off-the-shelf tools, whether you're targeting a custom ASIC or you're targeting FPGAs. And we're wrapping this into a platform that allows you to use arbitrary FPGAs from many different vendors and to simply take your code, run it on the CPU, and then slowly port a function by function into custom accelerators for you. It works for code. It also works for ML models because an ML model is just a different type of input-output transformation. But where this approach really starts shining is especially in robotics, when you want to give your hardware accelerators the agency. They should be able to listen to the inputs and control outputs without having to wake up your slow CPU. And when you allow them to talk to each other, you start being able to build up larger and larger systems and really get the benefits of hardware acceleration. And in terms of results, we apply this, for example, to common workloads like, let's say, text search. It's common from anywhere from DNA sequencing to kind of deep packet inspection. You run the best possible program out there for text search, and on 32,000 characters, it takes 2.66 milliseconds. A 40 lookup table large piece of hardware gives you an 8x speedup. An infinitesimal amount of hardware is able to just run circles around your CPU. And because this is hardware, you can scale it as much as you want. You can create more and more units and get linear speedups out of it. So that's really the benefit of custom ASICs. And there are this class of chips, FPGAs, it's just they're really hard to program. And that's the problem we're really solving here, right? And while we initially started targeting chip designers, we found that embedded developers really have a need for acceleration without getting bogged down with multiple years of chip development, right? So we're really in the business of solving their latency needs, often safety needs in robotics where dealing with scheduling might be hard, and fitting within some size, weight, and power constraints, right? We find that robotics is actually an excellent place for FPGAs because, first of all, a lot of companies in the robotics and drone space already have to use them due to really tight latency budgets. And the second part is really everyone is shipping all of their compute on the edge, and they can't rely on a data center where they might be able to buy more expensive hardware. So they need custom chips. And what we're seeing is that there's this sort of a missing middle that we're really trying to serve in between microcontrollers and kind of high-powered GPUs and high-powered FPGAs, coming from examples on Xilinx. So we're enabling companies to target FPGAs without sacrificing their time to market, right? But not just that. It's not just time to market. It's just the lack of talent right now, especially domestic talent that knows how to design and program digital logic, is what we're enabling companies to do. On the leadership side, my background's in ML mostly, but I did a PhD in computer architecture. Our head of hardware has 10 years at MIT Lincoln Labs and was the head of hardware at QEra, a quantum computing company, where they were controlling individual atoms with FPGAs. And on the compiler side, Ivan has a PhD from MIT in software synthesis. And I will stop here and take any questions.
Cool. Thank you so much, Mahalo. I'm happy to start to get folks warmed up, but I would love to give some time for other people to talk. All right. I can yeah, can you give a few use case industries that you think that this could, change things dramatically for? Just to
So we're finding robotics has a lot of these compute sinks, basically places where 100xing the amount of compute really translates into a quality of service improvement. A lot of the control loops, a lot of the motion planning algorithms can benefit from extra compute. And for a lot of robotics workloads, GPUs are just not the best solution. The workloads are often relatively diverse and need really the kind of heterogeneity of custom digital logic that FPGAs can provide you. So think anywhere from optical stabilization to, let's say, motion planning.
Sure. And then there's a question in the chat. What's your traction of real cases or real use cases or end users?
So we are working on mostly open source applications and building up a sort of a zoo of applications that work out of the box with FPGA acceleration. And we are launching a private beta and a public alpha in 3 and in 6 months.
Nice. Gonna let other folks. Gonna give a chance to some other folks. It's time for a question. All right. Give another few seconds for someone to come in on it. Otherwise, thank you so much, Mahalo, and feel free to leave your contact information in the chat. I'm sure there'll be some interest there. And thank you for the presentation.
Thank you. Thank you.
Absolutely. All right. With that, we begin the third session. For everyone who has stayed with us the whole time, I'm impressed. Thank you for sticking with it. For those who are joining, welcome. We're going to quickly introduce the panel for session number 3, and then we'll get right into it. If you just want to say hello, that and what organization you're part of, I think that would suffice because there's a lot of probably a lot of repeat folks. So to get started, Ben Patterson, you want to introduce yourself?
Sure thing. I'm Ben Patterson. I wear three different hats. I'm a partner for the Coors family office, general partner for Elementum Ventures, which is focused on pre-seed deep technologies. And then 10 VC is really a continuation of my work with Coors. They're the anchor for the fund external to the family. This is a generalist fund, but with a significant amount of deep tech investments out of it, also pre-seed focused.
Nice. Thank you for joining us. Next up, Max. You want to say hello?
Hi, I'm Max Jurgen with SLI. We provide capital primarily to companies in space and advanced aviation as well.
Nice. Pleasure to have you. Lisa?
Hi, Lisa Dufresne, GC Ventures. We are a petrochem refinery in Thailand, and so you're probably wondering why I'm here. But we also sort of liaison with 4 or 5 different companies in the PTT family of companies over there in Thailand, and many of them have defense interests. And so I'm sort of, as the only team member in North America, just looking out for the fam. Thanks.
Thank you for joining. Todd?
Todd Coulard, I'm a principal at Market Ventures. We focus on early stage defense, focus on seed through Series A.
Perfect. Pleasure to have you. Marissa?
Hi, Marisa McGinnis. I'm in Silicon Valley, and I'm a limited partner with the R42 Group, which invests at the intersection of AI and longevity.
Absolutely. Pleasure to have you. Lucas, you're next.
Hey everybody, my name is Lucas Snevice. I am an investor with Booz Allen Ventures. We're the strategic arm of Booz Allen Hamilton. We focus on seed to B across cyber, AI, deep tech, defense tech, and reindustrialization.
Absolutely. Pleasure to have you. Bahare?
Hi everyone, Baharo Ajisai, Technology Scouting Director for BAE Systems.
Pleasure to have you, Bahare. Mike?
Mike Telside with the Space Force out here in LA, Los Angeles Air Force Base, Space Base Delta 84. I do most of the space sensing, weather, satellites, and missile warning, missile defense.
Absolutely. Pleasure to have you. And then Wendy, I see you're still here. If you want to join, you can. If you want to introduce yourself, you can. But up to you. I know that you are supposed to be on for just the last one.
You're still here. I'm Winnie with Ajinomoto Group Ventures. We invest in deep tech companies, especially the ones that have a material angle.
Awesome. Pleasure to have you here. All right. With that, we'll get started with the third and final session. We're going to start off with Caliburn, if you guys are ready to present.
Yeah, rock and roll. How is everybody today? I'm the first up. I feel like I'm going like after everybody's had a big lunch, and I'm coming in at the end. But from everybody who just introduced themselves, Marissa, take a break. I'm not doing anything on extending longevity. This is a good time for you to get a cup of coffee, unless you care about the longevity of boats and autonomous weapon systems. Let me jump in. I've got some slides to share here, and we'll just drive through that. All right. Asher, are you seeing these?
Yep, I am.
Great. All right, let's rock and roll. So I think everybody is aware that the congressional budget is shifting as the United States, tries to implement what one of my colleagues and I articulated several years ago as the hedge strategy. How might the United States, reinforce conventional deterrence with an affordable, scalable force of the small, the agile, and the mini, powered by AI, robotics, sensors, and advanced cyber to protect them, since they're so software defined. As soon as I talk about anything I'm doing in the unmanned space, the first question I always get is, are you working with Anduril? Yes. Have we already integrated in production with Palantir? Yes. We are an actual company that is building a real operating system where Lattice OS Andural's product is actually an application layer built around the idea of bringing things together. So they call it an operating system when in fact we're from the silicon to Kubernetes. We have kind of a growing mission bay of partners and customers down there at the bottom. And I think what's differentiating what we're doing in Caliburn is we see this new ecosystem as a collaboration among the startup innovation ecosystem and the proven weapons, sensors, command and control links that have never missed a target in 3 years, over 30 years, in 30 years of almost continuous warfare. So how do we bring those two together? What we're really talking about to get this done in 5 minutes is there is an emerging cyber physical convergence of machines, AI, and effectors. The DoD has now, Department of War has one of the most intense use cases of making that work under all out and immense cyber attack pressure from China. But at the civilization scale on the far left, as every robotic system right now is a bespoke, tailored entity. And as the robotic and cyber physical systems converge, we're going to see layers emerge. This is the operating system layer for cyber physical convergence and in a defense go-to-market play with autonomic and robotic and autonomous systems. And so let's talk about the problem we're solving. There is an integration problem in the United States that creates innovation from reaching warfighter scale. A friend of mine who runs a company called BMNT likes to say, the United States does more cool tech demos than anybody else in the world, and the Chinese builds 10x more ships. So they're fielding at scale to the warfighters. We are not, and the problem is this middle largus of integration and certification. Something I've been successfully hacking for a while. What are we doing? It's a product-based approach where we're getting rid of a bunch of antiques in the stack. VMware, Red Hat, Rancher Kubernetes, and we're actually building a debloated Titan cyber secure operating system that does everything that DARPA and ONR and AFRL have been saying we should do for cybersecurity for 30 years. But Windows wouldn't do it because they couldn't give a flip about operating systems because they're just trying to drive Azure consumption. Red Hat won't do it because they're a consulting company built around a free product. And now we're about to build the foundation of freedom and AI on robotics on a squishy Jello foundation. And that's just stupid. So kind of if you think about this at a macro level, we are the operating system that allows the ecosystem to function on a backplane of common shared data in a trusted environment. iOS did that and built a $1 trillion company. Amazon did that with their AWS infrastructure and built a $1 trillion company. We're going to build a similar operating system at the integration layer for robotics and autonomous systems with all of the AI, ML workloads, weapons, and effectors as payloads on them. Yes, we're real. We are already deployed on 2 warships, fully ATO'd and certified. We've got about 34 companies in the pipeline, a conservative 2-digit $1 million of revenue projected in 2026. We're raising a $7 million seed round to actually go from my personal, I angel funded the first 4 million to get us to where we are now. We're raising a seed to take us through the next level of product, proving the business model is scalable. I've done a lot of cool stuff, including building the Navy's first AI program of record, as opposed to an experiment. I've got what I consider to be an innovation defense dream team, from PhD level expertise in both autonomy and cybersecurity to an engineering lead who actually is one of the few people that actually reprogrammed Aegis destroyers to shoot, higher end missiles. That Steve Blank is on our advisory board, as well as the former chief engineer of the Navy, and just a wonderful team of people. What does that give us? We have personal multi-decade relationships with all of the deciders in our market. Everybody from the CNO who's texting with people on my board, to Admiral Ocano and the new PAE Raz, to the former Undersecretary of Acquisitions, and House and appropriations leadership. And on the industry side, have just a strong teaming approach that's encouraging a lot of people to jump in. What are we going to do with the seed? We're going to meet the demand. I have a funnel that I'm understaffed to close. And there is an opportunity as the Department of War shifts from what I would consider their angel phase of playing around with autonomous systems to organizations like DIU and SCO and OSW R&E and others, to where they actually buy in the billions instead of the tens to hundreds of millions through the existing new portfolio acquisition executives that have been stood up. There's an opportunity to shape and define how that market works as a payloads and platforms marketplace. And that's what we're going to get done over the next 12 months. We like the term orchestrate the storm. There is a lot of great ideas and innovations coming. And we understand and know that there will need to be an operating system that makes the payloads interchangeable with regionally optimized and appropriate platforms. So I think that was 5 minutes. Asher, are you timing people on this?
We give a little leeway, but yeah.
We give a little leeway. So I would love to answer questions as opposed to just kind of, talk at the room. So, fire away.
Yeah.
Zach, go ahead, Todd.
No, go ahead, Ben.
I was just going to ask the difference in 12 months of runway and 18 months of runway that's a big diff. What are the factors for your use of funds?
Yeah, the 7 million is 18 months of projected runway. I think what we're saying is if we believe we're on track for a 2027 congressional appropriation. I've been told that by the chief of staff of HACD. And so we, the consumption rate, we would accelerate if we had other non-dilutive source of funds. So that's where the 12 comes from. But in a most conservative estimate, it's 18.
Sure,
yeah, just to say the traction is awesome and super cool to see. Can you talk about any obstacles you had to integration?
So integration is what we think the government's problem is. I actually think acquisition reform, which we've heard a lot of over the last 4 months, is kind of is also true. Acquisition reform is, in my opinion, a necessary but insufficient condition to deploy innovation at scale. And so what we've done is, I've done a bunch of defense integration projects, and what I've come to realize at an ecosystem level perspective is the defense innovation ecosystem really needs two kinds of innovators. It needs a lot of the companies we've heard about today who have a brilliant idea. It's never been tried. It's super hard. That's why it's venture instead of going to chase. And some of them are going to succeed, and that's America's decisive advantage. And then it needs old dudes like me who have gray hair, who actually know how all the programs of record work and what the technical integration surface looks like, to come along and smooth that surface so that actually innovation can deploy to the force at some sort of relevant pace and scale. And so the challenges we've had have been about building the long-term relationships with primes over the last many years in my first company. So when I come to them now and I say, hey, we're going to be your integration platform for the RAS market, they're like, okay, Zach, yeah, we trust you for that. And I think the coolest evidence of traction on that one is that Northrop Grumman is about to write their first value-added reseller agreement to Gallivern that any of their lawyers, they don't have a template. Northrop Grumman has never given a VAR agreement to a reseller before. But because they're going to let us resell their radar, EW, laser designators as payloads that are pre-integrated on Tempest, that gives them broader access to the RAS market that they otherwise wouldn't have, trying to pick which one of all of these different little robots is the one that they should spend their IRAD on. So I think relationship and trust building, as opposed to a technology problem, has been our most successful integration hack. And it's exciting now to see it take root in signed agreements.
Awesome. Thank you.
You bet.
Sure. Mike, did you also have a question? I think I saw you.
Yes. Zach, thanks for your
Hey, Mike.
presentation. It is very important problem that you're solving. I spent most of my career in acquisition. Yeah, you're tackling a great issue that we
Yeah.
have. So just curious how you handle security, all the different security classifications, all this different security handoffs.
Yeah, you're right. So you want to talk multi-level security and cross-domain solutions for
Yeah,
a moment? Okay, good.
yeah.
So most of so as you're aware, NSA released the raise the bar requirements, and they released the raise the bar requirements as opposed to shutting down all the existing MLS solutions for security vulnerabilities because we couldn't afford to do that while we have active operations going on that rely on cross-domain and multi-level security. But fundamentally, we've built cross-domain solutions now as unscalable ways to actually do the high to low, particularly low to high data transfer we need to bring our massive amounts of IL4, IL5 data up to IL6 and SCI. And the reason why we haven't been able to build a scalable solution is because the current operating systems that you need to have suck. They are general purpose operating systems built. So, Linux in particular is built so I can do everything from, this Mac, I can, adapt it into Mac OS to, a home video controller. So most weapon systems that have been disastigged um, have all this bloat in them that is just turned off that shouldn't even be there. So, for example, one of the STIG requirements in Linux is to turn off all the sound drivers and the GUI when it's running headless in a system. So most weapon system has sound driver engines in them and printer drivers and all this ridiculous stuff that's turned off as part of the stigging. So then you go to build an MLS system on top of this OS that was never really meant for high security applications, and you end up with a lot of vulnerabilities in the foundation of that. That makes it so then you have to build a very bespoke CDS. So to get to your question directly, when you build a lockdown, highly tailored, very secure operating system, you can now operate cross domain at the application layer because you have a trusted foundation. And once your application operating cross domain at the application layer, you can scale it into cloud native patterns across lots of distributed assets so that go back to your 1,000. Let's go to something very practical. I've got 300 assets swarming around the South China Sea doing unclassified bathymetric ocean measurements. I need to raise that data up into my tactical sonar prediction environment. So I need CDS. So all of those things have to be feeding an environment that allows me to do that CDS. And Tempest OS is the first way to scale that cross-domain solution to come up with a massively informed sonar prediction model for the South China Sea, for example. But you've asked me one of my favorite questions. I could go on for about a day at a whiteboard, so I'm going to pause. But but yeah, please reach out. We'd love to talk about security more, particularly and
Thanks.
your use case in Space Force is one we're very familiar with. We'd like to talk about.
Sure.
Thanks,
Thank you
Zach.
so much, Zach. And
Yeah.
to take a page out of your book, speaking of, we're running out of time. So thank you so much. There's some questions in the chat that you should probably answer. It looks like there's at least two, if not more, unless I'm reading them wrong.
Yeah. So I got the one from Samira. Love that one. And what else do you got?
Suresh, I'm not sure if that's for you or if it's for someone else, but it looks like it's for you based off of the timestamp. Basically,
Yeah.
he's asking for historical data for scale and organic growth and inorganic growth, which I think is probably a longer discussion.
Yeah. So Suresh, I think the M&A versus or organic is I think important. It's a very Christensen sort of innovator's dilemma problem where you buy innovation, you try and run it in house. We as a startup are not doing M&A. And so not really applicable to us. It's great coffee conversation. And then for Samira, Where do we see the product revenue overtaking services, if at all? 100%, Samira. What I like to do is repeat proven working ideas with new technology. So our proven old school working idea is IBM. IBM in the 1960s it was trying to sell mainframe computers, and nobody knew what one was. And so they had a services division that taught people, hey, if you had business computing, this is how you could actually make your business better. And then as soon as people were like, oh, yeah, okay, I get that through the services engagement, they turn around and IBM sells them a computer. So we are very much in the domain of a near term, probably long term, early stage services model that is product embedding. So we do a service that embeds a product that has ARR, and it both allows us to gain and sustain reputation, as well as embed product that has long term revenue potential.
Sure. Zach, I think we need to move on to the
Yes, sir.
presentation because
Thank
we're
you. I
running late.
appreciate it.
Yeah,
I get it.
yeah, absolutely. All right, next up we have Seafloor Systems, and thank you, Zach, for the presentation. It was really enlightening. Hey, John, I don't know if you're talking, but we can't hear you.
Sorry, guys, I don't use Zoom typically, but can you see my screen?
Yep.
Oh, super great. All right. Let me bring that up again. Okay, let me share that. I'm having trouble here. Okay, anyway, good afternoon. I'm John Temple, and I'm the CEO and founder of Seafloor Systems, former U.S. Navy EOD and sonar technician. On here. So who is Seafloor? So I'll start out with saying we're not your conventional startup. We have over 1,200 of our unmanned platforms out in the field. We have over 220 distributors worldwide. So we have a pretty worldwide reach for our unmanned solutions. Where did it all start? Back in 2014, land surveyors didn't want to get in the water, especially in Florida. So we built kind of a little miniature drone for doing land surveying. And then it's kind of escalated from there. We're now the worldwide leader in these types of systems. ASVs like AUVs have really have an extremely upward trajectory, especially for the commercial and government. And as these users adapt the unmanned systems, we continue to develop new platforms to meet and exceed their requirements. Start with some commercial survey and inspection applications for infrastructure, channels, oil and gas. These are really surging for us. Land surveyors, engineering companies, offshore wind. Defense applications, adapted by NAVFAC and the U.S. Army Corps of Engineers for survey and inspection currently. And then we're seeking Department of War stakeholders. This is the newest platform we developed from feedback from NavOceano. They wanted a small USV that was U.S. Air Force 463 pallet compatible for ease of transport. And this led to this enabled us to build a system that actually had exchangeable payloads. And this was exchangeable in a matter of hours as opposed to days with existing systems. We talk about attritable. A lot of manufacturers claim they're attritable, but are they really? Just calling it attritable doesn't really make it so. We offer up to a 20-to-1 efficiency with the cost and usability of our platforms. How are we going to scale? Well, there are over 4,300 small aluminum boat manufacturers in the U.S. alone, all with some excess capacity. And that's when they're not on a Wartime Defense Production Act mobilization status. We've actually worked with a couple of these folks, North River, Brighton Marine Group, in the past to help us develop platforms and scale platforms for the government. Are we compatible with the U.S. government? The U.S. government has established an autonomy architecture for unmanned platforms. It's called UMA. We are compatible. We proved that at a recent U.S. Navy exercise held in Michigan called Silent Swarm. Uh, we have a familiar integrated user interface integrated with the Xylem HiPAC ecosystem utilized by all the U.S. government vessels worldwide. Autonomy, mission planning, ISR, and situational awareness are all at the operator's fingertips. And then on the commercial traction side, two of the largest government users, NOAA and the U.S. Army Corps of Engineers. NOAA is typically the first to respond to air tragedies such as the DCA crash or post-hurricane seaway mapping and clearance, whereas the U.S. Army Corps of Engineers, they're tasked with maintaining all the navigation channels inside the U.S. borders for commerce. And then on the commercial side, one large one is the largest program in U.S. and Virginia history. It's the Hampton Roads Bridge and Tunnel Connector program. They have three of our platforms operating on this platform, on this program, 24 hours a day for survey and mapping as they build this tunnel bridge system. And on the defense side, following that Silent Swarm exercise that we did in Michigan, we signed agreements with Northrop Grumman and also MITRE Corp to provide platforms for their development. So what are we asking for? We're asking for a DOW partner for scaling offensive defensive manufacturing. We're interested in SBIRs, partnerships, innovative partnerships for USVs, combining USVs, UAVs, and UUVs, and innovative integration, sensor integration. Our capital ask is around 5 million, around at 50 million pre-money valuation to help us rapidly scale. And there you go. Any questions? Here's my contact info as well.
Sure. Opening up the floor.
Hey, John, I have one. Yeah, it's great that you are leading the pack there. But what's the secret sauce? What makes yours? What's the moat around your what you're doing?
Yeah, it's our integration, our sensor fusion integration with our control panel. We integrate with a lot of the commercial and DOW infrastructure systems. So as far as data acquisition and data processing, mission planning, those are all integrated as well as a C2.
Thanks. I like how we go back to all about integration, right?
Right.
Thank
That's
you.
right.
Yeah.
You're welcome. Thanks, Mike.
So,
just have
hi, John,
a quick.
for your presentation. So you build the USVs as well? I saw the platform, right?
That's correct. We do. We build the USVs here in our California facility.
Okay. So how do you compare with Saronic?
We actually build USVs and we have them in the field working.
Saronic did too.
I don't know what to
Okay.
tell you. We have more than all of the other manufacturers combined out actually working in the field.
Yeah, I was just like, how do you differentiate yourself from the others? That's my question, I guess.
Yeah. So I mean, our platforms are geared towards high resolution survey, mapping, inspection, surveillance, as opposed to they're building platforms. And I'm not sure what I think they're just typically for ISR applications.
Okay. All right. Great. Thank
I had two questions. One, what is the round? What are you guys calling this? I know those definitions are kind of weird.
Yeah, like I said, we're not your traditional startup, but we are looking for a seed round to develop a defense group.
Okay. And then second question is USVs are becoming table stakes. Are you seeing like a lot of companies reach out to you guys for like mapping data, or you have any plans there to be strategic partners with, a Saronic or anyone like that?
Yeah, I mean, we've talked to Saronic and a few of the others. We're not really into on the acquisition side or data acquisition side, and data collection side. We're more into sensor integration, fusion with the vessels, and swarming. So our customers, especially the U.S. Army Corps of Engineers, they want to be able to have 10 platforms following their manned platform as they survey a 2,000 wide channel, and EOD and ASW and the mine warfare has a similar requirement.
Awesome. Thank you.
Thanks.
Cool. I think we have time for one question. I think I heard someone asking before. Otherwise, I could just ask. Someone asked about operating systems, like what operating system is running on the USB.
Yeah, it's all open source. And again, the U.S. government is really pushing manufacturers towards open source manufacturing and open source software. So we're using I guess it's called oh gosh, now I'm blanking. It's open source for same as the aerial platform. So we use the same flight controllers the aerial platforms use.
Sure. No, that makes sense.
Open
Awesome.
source, but we're integrated with the Xylem HiPack data collection mission planning system.
Sure. Absolutely. I think that's all the time we have for now. Thank you so much for the presentation. There's at least one or two more questions in the chat. Take your time, look through them, and if you want to leave some contact information, I see it's on the slide, but if you want to put it in the chat, you can. Thank you so much for the presentation. Sure. All right. Next up, we have Tom George from Serenia Sat.
All right. I'm just gonna.
I'm
Can
ready.
you hear me okay, Asher?
I can hear you and I can see you.
All right. Very cool. So let me know when to start and I can do
You're
that.
good to go. Whenever you're ready.
All right. Hello, everyone. My deep thanks to Deep Tech Showcase for inviting my company, Sarnia Sat, to pitch today. I have one caveat. This is not a investment deck. It's more of a capabilities deck. And I'm really excited to present our Hemi solution that got my company, Sarnia Sat, selected in the prestigious NATO Diana 2025 program. Let's see. Yeah, there we go. So a little bit about NATO Diana. NATO Diana is an accelerator headquartered in London and aimed at developing a wide range of technologies for use by NATO allies to face current and future threats. Of the 2,600 companies that applied, my company, Sarnia Sat, was one of the 76 companies selected for our expertise in sensing and surveillance. So what exactly is the Hemi solution and why do we need it? As you are all painfully aware, the ongoing Russia-Ukraine war has created a major paradigm shift in battlefield tactics, namely asymmetric warfare, whereby a swarm of relatively cheap and nearly undetectable drones can take out far more expensive military hardware such as tanks, planes, and ships. And because these drones present extremely small targets, and there are many of them, we need new and revolutionary approaches to not only identify individual drones within a swarm, but also to track them with a high degree of certainty. And therefore, Sarnia Sat's Hemi solution is aimed at multimodal sensor fusion achieved on ultra-low swap edge computing platforms for rapid and robust drone identification and tracking. The team we put together to win the NATO Diana competition included Sarnia Sat as the PI, the NASA Langley Research Center, SRC Incorporated, and Air Force Research Laboratory. And now a little bit about individual team member capabilities. My company, Sarnia Sat, successfully demonstrated airborne moving target identification of a single flying airplane within a highly cluttered 100 square kilometer satellite scene in under 45 seconds using our deep learning algorithms operating on a high performance edge computer. Our team member SRC successfully fused video camera imagery with event camera imagery to identify and track a single flying drone. NASA Langley Research Center's portable infrasonic microphone technology successfully generated 2 simultaneous micro UAV tracks. And finally, all of these multimodal sensor inputs are then fused on the Intel Lohi 2 neuromorphic chip available at Airforel RI using spiking neural network algorithms. As part of the NATO DIANA program, I received funding for a test, evaluation, verification, and validation, or TEV program, where I partnered with a NATO test center called Area XO based in Ottawa, Canada. Our TEV program culminated in a field demonstration in early November 2025 to a NATO defense community consisting of representatives from the Canadian Armed Forces, Department of National Defense, and NORAD. Area XO is a research and development complex that helps accelerate time to market and commercial adoption of next-gen technologies. I will now talk about the Area XO facilities and assets used for the TEV demonstration. Area XO has sophisticated urban environments as well as rural environments for testing our Hemi solution. They have a broad range of multimodal sensors, including these sensors, and many different types of drones, including these drone types. And now I'll briefly describe the experimental design and execution of the TEV project. We executed a three-phase TEV project, with each phase being approximately 2 months in duration. And here is a pictorial representation of the overlapping fields of view of the various multimodal sensors that were used for drone swarm identification and tracking. We've learned a great deal of valuable lessons on sensor performance, both individually and as an ensemble. This is a snapshot of the results from the different sensor data for 2 different drone types. And these are individual sensor responses for a 3-drone swarm. And we proved that sensor fusion does indeed improve the accuracy and precision of the drone identification. And here are a few key takeaways from our testing and validation of the Hemi solution. Finally, I would like to end with a quick snapshot of some exciting future work, and I'm very glad that Barry is part of the panel. The drone world is getting increasingly sophisticated with the introduction of jet-powered drones that give you almost no time to react. This is why I'm glad that Barry is here, because we are hoping to have a collaboration with BAE Systems in combination with a Finnish company called Kelu, and we are trying to put together an effective early warning solution for these jet-powered drones. So with that, I'd like to thank you for your attention, and I'm ready for questions.
Sure. Thank you, Tom. Opening the floor. Whoever wants to talk, because I know the reaction button's hard to find.
Let's see what's happening here.
I can ask the first one if
Go for it.
I'll so in terms of recognition, I'm just curious, have there been ways to mitigate, like, I know for other, in terms of heat signature, I know that, like, for example, jets have ways to mitigate heat signatures. In terms of what you've been seeing, do drones, have they developed anything to mitigate that, or is it a relatively, precise, people can't really avoid the heat signatures that come with drones because they're running on batteries and they haven't figured out any kind of ways
Oh, you
to
mean
mitigate?
using thermal infrared
Yeah,
as a
yeah,
detection modality? Yeah.
yeah.
I mean, optical techniques don't have a large amount of range. It's about at best about 300 meters or so. So heat signatures also would be in that range, and plus there's a lot of clutter in the environment, as you can imagine. So
Sure.
it becomes a range and a signal to noise problem.
Sure.
Yeah. Thanks.
Yeah, absolutely. Uh, Yeah, we have time for a few more questions if someone wants to be brave.
I guess I'm pitching to the wrong crowd. I mean, this is more of an investment crowd, right? So
Yeah. No, but I'm definitely. Someone asked, "What's the current TRL or TRL level?"
yeah, I would say we've done field demonstrations, so that's I would put it at TRL 4 or so. It's not a prototype system as such that's customized to a particular application. So it's not very high maturity, but we have got some really good field data.
Sure, absolutely. Also, there's the NATO Diana, obviously, which helps move things along too.
Right. Exactly.
Yeah.
So that was the driving force behind it.
Yeah, absolutely. Cool. Last chance. If anyone wants to ask a question, go ahead. Oh, we have another one in the chat, but if someone wants to ask, we can. When do you anticipate doing large constellation detection?
Large constellation of drones or spacecraft?
I would assume they probably, I don't know if drones, they said drones in the chat.
Drones. Yeah. Yeah, so that's the point. The point is that by using multimodal sensing, we can track individual members of these constellations, or I mean, they're called swarms. I guess that's the operative word for drones. And so being able to track them and also discriminate between dummy drones that are not carrying a payload, for instance, and those that are, and thereby target the mitigation more accurately.
All right, cool. Thank you so much for the presentation, Tom.
Right.
I enjoyed it.
Oh,
Yeah,
good.
absolutely. And so,
I just wanted to say shout out to Bare and say hi. It was good to see her
Yeah,
on the
just
panel.
wanted to say hi. I don't have any question for you.
Right.
But hi.
Thank you, Bare.
Good
Thank
to
you,
see
Bare.
you.
Bye.
all right, perfect. And next and last presentation of the day is Dr. Modi is going to be presenting Aeronaculus. So whenever you're ready.
Yeah, just one second. Can you see the screen? Can you see my presentation? And just one second, I'm just going to try to make sure that it's full screen. All right, perfect. Can all of you see the presentation?
Yeah, but for some reason there are some gray boxes.
Yeah, I know. I don't know why that happens on Zoom.
Yeah.
So please bear with me. I don't know. Like that's kind of like. So first of all, my name is Apurva Modi. I'm the founder and CEO of Aeronaculus. I do see some familiar faces. So hello in advance to all of you. I founded the company called as Aeronaculus in 2019. Aeronaculus stands for Artificial Intelligence for Radio Access Networks and Oculus for Vision. We do autonomous intelligent reconfiguration or self-driving for heterogeneous wireless networks. So simple things like, when you deploy Wi-Fi at your home from Xfinity or Verizon, and they never check whether your Wi-Fi is on the same channel as everybody else, and as a result of which you don't get 150 megabits per second of capacity. But then that problem becomes worse and worse as you go into 4G, 5G, for example, and experience all kinds of interference issues. And even licensed spectrum has got interference issues. And then you go into mission critical, for example, NASA or Department of War. And so essentially, we do cross-layer optimization. And so we have a ton of different programs in this particular area. Just to give you my background, I did my PhD at Georgia Tech. When I was at Georgia Tech, I had about 5 patents that became extremely valuable. They got integrated into Wi-Fi, 4G, and 5G standards. I'm a fellow of the IEEE 25 plus patents, and also I'm the former chairman of the National Spectrum Consortium. I got reelected to the board of National Spectrum Consortium. So, continuously I have been on that, on that prestigious organization. Our team consists of extremely well-recognized folks or individuals who have worked for Samsung, Bell Labs, formerly with BAE Systems as well. And we have a pretty successful team of both commercial exits as well as track record of government business growth. So just to give you a little bit of insight into where we stand as a company. So last year, we ended up winning this DIU Defense Innovation Unit RF Spectrum Sharing Challenge. We outperformed 17 other top-tier industry leaders. And the interesting thing was that this was an 8-month-long intensive competition that was held in association with DIU and Air Force Research Lab. It was essentially on how we can use the spectrum in a better way. But it ended up becoming a second challenge because you have to actually do modulation recognition. And in the final round, they gave us like 3 scenes, 50 megahertz by 10 seconds with 700 plus signals, and we were able to identify majority of them. And that's the reason why we ended up winning this. So we actually got a follow-on order from the Office of Undersecretary of War, where we are now selling this capability as a license, and it's going to be deployed in several test and training regions. So since the inception of the company, we've done about $20 million plus in government contracts. Last year, our revenue was $3.9 million. We had anticipated 3.5, but we did 3.9. I'm a big believer in patents. So we already have 7 US patents granted, 12 US patents pending, and 58 plus global patent applications. On the commercial side, we are working with NVIDIA, Juniper. Radiusys is one of the largest. It's part of Reliance Jio, which is the number one operator in India. L3Harris, Lockheed Martin, and we would love to have collaboration with some of the companies that are there on this panel. We are on track for inclusion in NASA's Artemis moon mission. We are about 18 employees, 4 to 5 independent contractors. And in the previous round, we raised $1.676 million from investors. And this round, we are raising $2.5 million from investors. And the opportunity is that essentially, if we raise $2.5 million from investors, then NASA is going to match that funding. And we can do space flight testing of our technology. So we have a pretty strong track record of, government, executing contracts on the government side. Majority of our programs are SBIR funding. So on the Army side, we got $6 million plus of contracts. The majority of these contracts are going on. We are doing resilient wireless communications and position navigation timing, especially the issue of interference detection, characterization, mitigation on GPS is extremely important and challenging. And so we are solving that. We are doing signal-on-signal detection characterization. We are also using generative AI techniques. Army came to us and said that, we see new signals every day and we're not able to keep up. And can you use generative AI to develop synthetic data sets? So we are generating terabytes of data. And so we not only have algorithms for signal-on-signal detection and characterization, but we also have algorithms for generating the data itself. We are working on intelligent spectrum management, spectrum sharing between radar and 5G systems. We are doing anti-submarine warfare. This is a very important program for the Navy, and this could result in insertion of our technology into tens of thousands of sonobuoys. Very strong collaboration with Army as well as other agencies. So this is just a list of all the programs that we have. I think that this slide deck probably will be made available to some of you. So let me just talk about the products, right? So this is our first product. We call that Spectra, which is signal detection characterization. This was an outcome of the Defense Innovation Unit, our Spectrum Sharing Challenge. We used our own funding to develop this technology. We use all kinds of algorithms, statistical signal processing, machine learning on feature matrices, multimodal fusion, image processing. But the thing that we do really well is anytime there's an RF anomaly or signal on top of another signal or interference, we are able to detect and characterize, and we've got phenomenal performance. And that's one of the reasons why we keep getting funding from different departments. Our product number 2 is called Aeronacula's Resilient Cell. The name of this has changed. It's going to be called as Orion because NVIDIA stole this name from us. So NVIDIA is also calling their platform ARC. And so now we had to change it to Orion. On this particular product, we have a RFP from the Office of Undersecretary of War for a phase 2 SBIR funding. So it's going to be a $2.1 million contract if we win it, and hopefully we will. I mean, we are in a very strong position to win this one. And then the third one, which is product number 2, we call this Inspire, which is heterogeneous network optimization technology. And essentially, it's a very complex technology. It's a software that does cross-layer optimization, and it maintains end-to-end connectivity and quality of experience. So this technology is going to go into a CubeSat. We're going to do space flight testing. On the ground side, we're going to work with Nokia, NVIDIA, Radiusys, and Juniper. And then we're going to orchestrate this resilient communications for NASA. So if everything goes well, then the next thing that happens is that we will have the Artemis moon mission contract, which would be anywhere between $5 to $8 million. So the current opportunity that we have is that if we raise $2.5 million from investors, then NASA is going to co-invest. We were able to get term sheet from ARC Ventures, which is based in New York City. Along with ARC, we are getting investment from Charlotte Angel Funds and Andreessen Horowitz Scout Fund. So Andreessen Horowitz, they have a Scout Fund. So initially you get them excited. So they are investing Arca Venture Labs, East Coast Ventures, as well as Pranatech. And essentially the opportunity is that it's a pre-money valuation of $12.5 million, post-money of $15 million. The follow-on opportunity is about 1.5, out of which we only have $315,000 left. So if any of you on this call want to invest in us, this is a perfect time because there are similar comparable companies and their valuation is so much higher. And other companies, they just exited for billions of dollars, right? So, I mean, our pre-money valuation is extremely low at this point, and this is a great opportunity for you to invest as well. In terms of the strategic partner ask, we would love to work on Golden Dome. So we are not on any shield contract. So we would love to be on a shield contract. If any of the primes are on, they have won the shield. We would love to be subcontractors, and we can essentially provide insights into RF anomaly detection, characterization, interference detection characterization, Brazilian comms, PNT, and heterogeneous network optimization. JADC2, US Space Force, NASA Artemis, all those opportunities are there. So I mean, across the board, we work with primes, right? We work with L3Harris's and Lockheed Martins and Raytheons, and we also work with universities as well. And so if you see an opportunity, we would love to be partner with your organization. And also transition, right? So transition is one of the key things that happens, right? We develop some really cool prototypes, but we don't find primes that want to take our technology and then insert them into the product or large IDIQ programs that they might have. So if anybody here is interested, we would love to work with you on transitioning this technology integration validation, also program capture and co-development. I mean, sometimes what happens is that for other transaction authority, we get a call from large primes because they are not able to move that fast. And so we can be the primes. And so we've done that in the past as well, very successfully. And scale and commercialization. And again, if any of you, I mean, I know that all of you are extremely rich. So, we would love to have your $25,000 check so that we can get going on the fundraise. Okay. Thank you so much.
Sure. Opening up the floor for questions. Last presentation, so don't be shy.
Can you talk a little bit more about your IP strategy moving forward?
Yeah, that's an excellent question. So just to give you some perspective, another company, which is called as Digital Global Systems, they had 455 patents in this space, spectrum, and they got sold for $5 billion. We are developing our very strong patent portfolio. We are actually filing at least 2 to 3 patents per quarter. And so that's our strategy. And essentially right now it's a defensive strategy. In future, it may be offensive as well.
Do you need to license
Can you please
any
introduce
other
yourself?
IP? Oh,
Yeah,
sorry. My name is Ben
Yeah.
Patterson. Yeah, I'm a general partner for Elementum Ventures and managing partner for 10VC. We're both pre-seed oriented vehicles, although 10VC is generalist.
Okay.
Yeah, is there any IP that you have licensed that has a hit to your royalties or whatnot, or other IP that you plan to license?
In the past, yes. So I had 5 patents at Georgia Tech that were actually bought by BAE Systems. So I see Bahare here. So BAE Systems bought those patents, and then BAE Systems sold those patents to Intellectual Ventures. They ended up getting tens of millions of dollars from that. So I've done that before in the past. And so we plan to do the same thing this time as well.
I'm muted. I'm back. There's 3 questions in the chat. So Samira asked, what is the first product you would ship that has a measurable performance in a contested wireless environment?
Yeah, so the first product that we are already shipping is Spectra. Spectra has got, it does the signal-on-signal detection characterization and RF anomaly detection. And so that is that will be integrated by July into several nodes and at different testing and training ranges. And so this is a specific ask from the Office of Undersecretary of War. We also have received a RFP from one of the commercial clients on the 5G side. So we are going to integrate, we're going to work with them and develop a solution together. And then as far as the resilient 5G is concerned, we are working with the Office of Undersecretary of War, but we are also working with Lockheed to transition that particular technology into the defense sector.
Sure. And then the second question is, do you have, and by the way, if anyone wants to ask other questions, we can intersperse them between these ones, but feel free to speak up if you want. But do you have any independent validation or performance data against real adversarial scenarios?
That's a great question. A majority of our technology has been currently experimented in our lab. We are slowly and steadily taking this into the field. Again, like we would love to work with the large primes on this, right? So if you have a larger program or larger contract vehicle where you have access to that kind of scenario, we would like to work with you and see how our technology works. We will learn from that, and then we can improve it. So yes, I mean, we would like to do that with all of you.
Marissa, go right ahead.
Okay, I'm interested. So how do I get a pitch deck?
Sorry, I can't hear you. Can you? Yeah.
Okay, I'm interested in investing. So how do I get a pitch deck?
Oh, okay. Oh, absolutely. We would love to send you the pitch deck. So I will send you the pitch deck, and we can also send you the access to the data room. And yeah, we can have a follow-on conversation. But that's fantastic. Thank you so much.
Thank you.
Sure. And then there's one last question on this one. Actually, maybe we should someone else asked, how do you detect or protect your IPs being used by incumbents?
So right now, currently, our IP is defensive. It is essentially protecting our product. In future, we will be looking into this as well on what kind of intellectual property is being developed by other organizations as well, and then we will we will be going in that direction. But currently, it's a defensive IP that we've developed.
Yeah, and I think this is going to be the last question because we're running through it. But do you have a first paying customer, and what problems specifically are you solving for them?
Yeah, the first paid customer is actually Parsons Corporation. So Parsons is a large, defense contractor. They do everything from electronic warfare to building bridges, and they have requested access to our second suite or Spectra suite, and so we are integrating that into their product. We are also working with a large systems integrator. They want to integrate our software into a USB. Like unmanned aerial system UAS as well. So we are working with a large systems integrator on doing that.
Sure.
Yeah, Purvak, can I have just quick? Good to see you. So are you talking to BAE at all about this?
I have tried to reach out to BAE, but would love to get connected through you.
Okay.
So
yes. Do you have my email? I can send you through LinkedIn if you don't.
Absolutely. Please do. Yes.
Sounds good. All right.
Perfect.
Yeah. Awesome. Perfect. All right. Thank you so much, Dr. Modi. And thank you to all of the companies and the panelists who have been able to join. We really appreciate the participation and all the work that everyone's put in and all of the time that everyone's put in. So thank you so much to everyone. Thank you, Dr. Modi, for the final presentation. Please feel free to join us next month for the AI, Cyber, and Edge showcase, I believe. And feel free to reach out to me. I will also send the emails and try to connect people where I can. But if we miss something, feel free to reach out. And have a good rest of your day, everyone. And thank you again for joining. Yeah. Bye-bye now.